Okay. Hello, hello. Welcome back. Alright, so last time when I was working on Cast, I was writing this, the comparison between Rust and Cast, and there's these things which are not all implemented, right? Not everything is implemented, so I think it's kind of weird that we state that something is not implemented in the very beginning here, so let's just fix some of those. Mutability should only be possible when the thing is declared as mutable. This is good. That's how it should work. Okay, so mutability. We have example .ks, I guess. There you go. Yeah. Wait, hold on. This actually already says let mutx. Wait, do I even have that? Let mutx. Oh, wait, hold on. We already have this as being parsed. Okay, uninitialized, not inferred. Correct. So what is mut then? But I cannot even parse this. All right, let's see. Compiler. Mut. Mut. This thing maybe? Macro let. Oh, it's probably just like a pattern, right? When I'm compiling a pattern. Yeah, so I'm compiling a pattern. Macro mutable pattern. This is it. Yeah, so we have a mutable pattern. And then we just say that everything that we are parsing inside is going to be mutable. Bindings are mutable is true. There you go. There you go. Okay. So bindings mutable. Oh, I already have it. Wait, hold on. So I already have it. It's even stored right now. We have bindings. And whether they are mutable is stored over here. Already, we have mutable. Okay. So it's just not being respected. That's it, right? Okay, so then let's go to a place. Right? So here's our place. And then we have place state. So it's either uninitialized, occupied, or moved out. But place. Okay, let's actually, let's have it as a separate module. Module place. Create a module place. Yes, yes, yes. Do that. And then I don't know. Use place star. To also have this. And that. Executor also is. I want to group everything that is an internal module, separate use block. Okay, yeah. Let's just move everything that is about places into this module here. Right now it's all over here inside the value. So place guards, this thing, display for place state. Yep, all of that. What's up, Ashmolive? Hello. And this also place ref. Place ref. You checking out my stream? Thanks. Huh? How did you see that? Are you spying on me? I didn't say anything in your chat, did I? How do you know? Or did I say something in chat? I don't remember. Maybe I did. That'll. Is this in the user list? I never look at the user list. Have a look at the user list. It was nice being on your stream, I would say. Do you stream for a long time? Oh, maybe it's because I followed you. If I followed you, then that's how you know. To my stream is empty like 85% of the time. Obviously, I check that. I'm not sure if it's a good idea to check if someone is watching your stream all the time. Like I understand, like you don't have a lot of viewers, right? So it's like this is the difficult part, right? How do you get your first viewers? Yeah, I don't know. That's difficult. That's difficult. How did I get the viewers? I was doing game jams. So like my first streams were having viewers because I was playing games from people from the game jams. So like it's basically how you easily know that people will come to your stream. That's what people do for game jams. They're looking for streamers who are going to play their game. If I didn't do that, I don't know. It's like starting starting out as a streamer is difficult. You need to figure out how to get the viewers. Compiler development thing, not very popular. No, I don't know. I think like people are coming to my stream because I'm doing compiler development. At least a couple. Some communities have channels where you can announce related streams. Yeah. I guess like in general maybe maybe like you see, so you like you come in chat, you talk in my chat, right? And we know that you are streaming, right? So we can have like a shout out like this, right? And maybe someone will follow you also. Like Commander Thrashden is also doing compiler development. I wasn't looking too close though what exactly your language is about, but I guess this is one way you can be friendly with other people in other streamers and then promote yourself. Do a sneaky shameless plug. Oh, I'm streaming too, by the way, you know. I'm doing LLVM. Yeah, I've seen that you are doing LLVM. I'm doing LLVM. So in a way, your thing is more advanced than mine because I'm not doing a compiler. I'm doing like an interpreter. I'm focusing right now on the high level details, and I guess you are focused on like low level details or something. I want to eventually to have low level too. It's not a priority for me right now. Rage compiler development. Duplicate. Place ref. Oh, it's because it's a duplicate. That's right. Because I moved it out of here, but I did not save this file yet. Yeah, this owned place 2. There we go. All of this needs to go into the place module. So over here we have everything about places, right? So what kind of places we have? We have place state. So this is what is the current state of a place. It's either uninitialized, occupied, or moved out. And that's the state. And then we have owned place, and we have references to places. And then a place is a place state plus the type of that place. And I guess also one other thing that we need to do. So we have like a place type, we have place state, and we also should have whether or not it's mutable. So mutable is a boolean here, right? Is a place mutable? Yes. It's a little bit weird though. So if I want it to be like Rust, Rust means that, so mutability is like transitive, right? It means that if I have, let's have another example, I guess. Transitive mutability. How about that? So I want to have a thing, right? Let mutable x be 1, 2, 3, right? Use std star. So obviously x should be modified, should be like mutable here. We should be able to do that, right? X, I don't know, plus equal 1. This should work, right? At some point yesterday, you got really tired of a certain bug and started yelling that one was crazy. But I threw something and then I realized it's a rage streamer moment. Your bug? Yeah. Bugs happen. LVM is also at fault because they decided to make all pointers art typed. It's like... well, it's a low-level virtual machine. It makes sense that it is untyped. It's literally in the name. LLVM is low-level virtual machine. You want something high-level if you want types. Like, I don't know. That's why I'm not. I'm probably not going to try and target like the low-level. Like I'm not going to make a native compiler first. Maybe I will like my plan was to actually go into JavaScript. Although JavaScript is also going to be untyped, right? Yeah, but there are other alternatives. We can go for, I don't know, .NET, or we can go for JVM. Is JVM? I mean, JVM is also kind of untyped, right? There's just objects all over the place. Basically, same as untyped. Oh, they did before LLVM 17? Yeah, I don't know. I haven't thought much about that. But yeah, I do agree that it's job of your front end, I guess. Once you are in basically the assembly, I don't know how far the LLVM is from assembly. It's not very far, right? You don't have types anymore, basically. You just have memory. Deep enough into LVM to ever even close to something like that. Okay. So we have this, right? Hold on, let me see why is stuff. What do you mean expected one argument from 0? There's literally 0 arguments there. It's in structure field mutable. Okay, let's get rid of the mutable. Let's just for now move all of like extract the place module, I guess. That's what I want. Fail to resolve. So value impl is what? Value impl is just something that is over here. Value impl. Yeah. Value impl. Match self impl. Place. Value read value. If it's in verbal, then I just clone it. Wait, read value gives me the value. Yeah. I don't know. I guess I can make this one public, but it's I guess maybe it should not be. To do not public. We'll see. And then value impl is a private thing, so this should also be not public. Okay, this should be working. All I did is just I moved all of the things about places to its own module. I didn't change any behavior yet. So we have this example, right? That's what I'm going to run here. And it's going to work. But so here is the thing, right? If I have like a struct which has a reference to X, right? We don't have mutable references yet, only these references. And then hi, for example, right? So I can say that foo.x, so foo.x is a reference to foo.0, I guess, is a reference to x. And I should do .0. This is not working right now. Let's say dot A is this and dot B is that. So that I can actually refer by name. Foo.a. So if I do dbg foo.a, right, this is going to show me a reference to 1 to 4, right? I've mutated, it's now 1 to 4. And if I say foo.a dereferenced is equal to 0, and I dbg foo, it should be an assignee expression. This is a place expression. Okay, this should be okay. I can fix this. It's just this on the left needs to be an assignee expression, but I guess the dereferencing is not working properly for that. Macro deref, this one. Yeah. So if I want to have an assignee expression, hello Nurzel. If I want to have an assignee expression, right? If this is compiled type assignee expression, then we return compiled assignee expression. I just do the same thing. Assignee expression into from place expression is not satisfied. Impl from impl into assignee expression. Impl from. Yeah, so we have like from place expression for expression, which means that we just read place, right? And we also should from place expression for assignee expression. We would say self place, where place is a place expression, right? Place data would be place data clone. I think. Mismatch types, expected assignee expression data found this data. Wait, what is assignee expression data? Is it a different thing? We have type span, and expression data is type span and contexts. Interesting. We might want like to be able to construct an assignee with like using some effects potentially, right? Like for example, we can do in like some structure at index is equal to value, right? Some structure at key is equal to value, right? So this is an assignee expression, but it has a side effect potentially of like, I don't know, allocating a memory, for example, or whatever else, if this is overloadable operator of indexing, right? So yeah, we can have some stuff there. Hello, Nigel. All right. Yeah, I think let's have this here to do should be same expression data and have assignee expression with effects. All right, but for now, I guess we just have assignee expression data. That data is place data. We just have that type is data type, and span is data span. And then it just compile now. There we go. Let me commit that. giraffe as question. Move place extract small tool. Okay, so here we go, right? Here's the mutability example again. This now works, right? So I have assigned this to 0 and now it is equal to 0. And what I need is so like this is not supposed to work, right? Because foo is not mutable. Even although x itself is mutable, this should not work, right? Haters are like campers. The most I'm a gamer bro ad ever. The most I'm a gamer bro ever. Hello, Jiggly Bits Donger. Although obviously, like right now, I don't even need this mutable, right? And it still is going to work properly. So let's first say that this mutable should work. Although, yeah. So like what I was saying is that we have mutability property on the place, right? So yeah, we have mutability property on a place. So like X is a place with int32 type, and it's a mutable place, so we can mutate it, right? But then if foo is not a mutable place, then whenever we like have some like place derived from that, it should. So basically, I think place expression. Whenever I'm calculating a place expression, it's not necessarily taking the mutability property out of the actual place. Something. Not sure yet. Let's see. Here's my place. Here's my place. I will have a mutability here. I also think that for some, so like some places are the places that I define manually, right? And some are transitive places. For example, if I have a list of integers, the first integer in that list lives in a place, and the mutability of that place kind of like depends on the mutability of the array itself, right? So is this even a boolean, or is this a place mutability? Enum, which is either read only, mutable, or something else, you know? Let's not use booleans anyway, because booleans is bad. Derive, debug, copy, bone, partial act, hash. Let's do that. So I have a place. A state of place is being used there, so I think this does not need to be public. Right? So here's my implementation, right? We have new state. So over here we need mutability in addition to the value, right? mutability, place mutability. Just have mutability like that. So when I'm reading a place, I can only read a place if we can, right? And we can only write a place if it is mutable, right? So yeah, if I want to write, let's have this public function. Yeah, I guess maybe something like self mutability dot read check can read. How about that? We just have checks on the mutability itself, and over here I say check can write. I probably always can read. Is there like a way? Is there a usefulness, some usefulness in the places that are not readable? I don't know. Mutability check can read, right? So basically we have this mutability. We have impl place mutability. Function check can read. It's just a result, like so. Read can write. So just match self. If it's read only, then it's okay. If it's mutable, then it's also okay. So it's always okay, right? And then for mutability, for write, match self. If it's read only, then I say error. Over here we say okay, right? Like this. Place is not right. Is not is read only. Something like that. So when I'm reading, before reading, I'm checking. Before writing, I'm checking, right? And over here also writing value, also self-mutability check can write. Take value is write. Take clone. Taking value is not necessarily like needs mutation. It should be not can write. Can write is a different thing. It should can mutate, I guess, right? Can mutate. But I want to be able to sometimes to like assign a value, right? Assigning should be possible if I am uninitialized yet, for example, right? So if a place is uninitialized, then the first thing is not actually mutating, it's just assigning the value, right? That's a little bit different. That's a little bit different. So I don't want that actually. What do I want? So we have like read and write, which is place read cards and place write cards. Are these being used in other places? They probably should not. Read write. So the public API is what? I mean, place itself is not public API, right? I think. Is it? I'm not sure. clone for owned place. Mutability should be the same. Yeah. Check. It's correct. Place. New impo. Inner place state. Owned place type. Why is this down there? Should I say place new state? Oh, this also like has the type. Type is not inferred. State type. Or a not inferred place type. Mm. Mm. Where is this being used? New temporary place reference. I see. What if I just have only a single constructor? New. So we have a place state. I also want to have type. Type and place state and mutability. State, type and mutability. Maybe. Is new. This would be place state occupied. Value. Type. Mutability of the temporary variable. Should be mutable. Right. So this would be, this is the owned place, right? Yeah, I want self new and place new. So state is the state. Type is type, and mutability I guess also should be here. It's a little weird. Sure. State type mutability. Just do this. New impl. Place data initialized. Type mutability. Like, because yeah, even if I have the new non-initialized, I still should have mutability here, and like yeah, value mutability is always there. Right. Place new. So this is when I'm cloning. When I'm cloning, this is the state. Zero type. Type is the same and mutability is the same. Okay. And now I want to have this mutability should be passed into all of the constructors, right? So for example, here we have a const let. A const let probably, so like this is a pattern, right? When I'm compiling a pattern is potentially mutable, right? Is that it? Because we have bindings, right? And over here, binding, inside of the binding, we know if the binding is supposed to be mutable or not. Yes. Matches, pattern match. Match. On place new. Value. Get ref. Well, I mean, this is a temporary variable, basically, right? Get ref. Yeah, I'm getting the reference here immediately. So it's a reference to a temporary thing. Yeah, sure. Yeah, we just have new value and mutability. Place mutability. I mean, in this case, it's not mutable. Read only, but it doesn't matter. I'm only basically reading it. I'm taking out of it. Would I potentially have places that we cannot move out of? Maybe. Place mutability failed to resolve. Place mutability. Is it? Yeah, it should be public like this. Yeah. So and then inside of the pattern matching, so we have a place reference, and I'm trying to pattern match this against a pattern, right? So we have a binding, right? And I know that I'm claiming the value from inside of the place here. And this is my match, right? This binding is now is now that. All right. Wait, so this is only returning a list of bindings and values. Yeah, it doesn't actually assign anything. So while we do this thing, then we just insert for the binding the values. This is the wrong thing, right? When I'm inserting into a scope, just the name of the variable and the value is not enough, right? It should also be about mutability. We have the compiler scope. Having mutable compile time variables. Is that something that I want? But in the interpreter scope anyway, where you inserting the symbols and values, right? And insert and initialized is the same thing, right? But the thing is, we need to know about the mutability of the things before inserting them, right? Because this is inserting. This over here, the locals, we construct a new owned place. And this now require mutability. as an extra argument when I'm when I'm inserting something. Like this. All right. So should be passed everywhere. So this is what is that? Template cast pattern match. So pattern match is the one that is actually inserting the matches into the interpreter. All right, yeah. This is once again just a temporary thing. Mutability doesn't really matter here. You can do a read only. It's fine. I probably want like to have like the temporary constructor here so that read only. Yeah, over here, instead of doing that, I just want to say new temp. Right, public function new temporary variable. This value. This would be just self new value mutability read only. I mean mutable, I guess. We can mutate first. Makes sense. Let me write this over here. Working on cast. Making. I am right now implementing mutability checks. Data should only be mutable if marked as mutable. Right? Function takes 2 arguments, but 1 argument was supplied. What is this? This is a place expression temporary. Yeah, this is a temporary expression, so we like to literally just do new temp here. Okay. Syntax module. Should this be making a temporary? Probably not. It would be new temp. Okay, what is this? So this is a list. Interpreter evaluating a list expression. Yeah. So the yeah. So in this case, right? If I have a list, what's the mutability of this place? I started to think that I'm doing it wrong. Is mutability a property of a place even? Is mutability even a property of a place? In this case of the list, we have nested places. So it should be place mutability. Should not be read-only. This should be the same as like, I mean, this is like nested. So it depends. Right? So for checking if I can do it, should always like say okay. It's nested, is that it? This is a temporary. Full function, temporary argument. Pattern match. Yes. Now we have 10 more errors. What is this? We have a variant. Owned place new. Value. Owned place new. Value. Place mutability nested. From tuple values. Yeah, values map. Value. Owned place new. Value. Place mutability nested. Sure. Inferable for list value. I mean, this is the same. We have it inside of the list. So if it is inside of the list, it's just a nested thing. Insert into the interpreter scope. So in order to insert something into the interpreter scope, I need to know the mutability, right? Mutability. Please mutability. Mutability. Like this. If I'm doing it in the compiler scope, if I'm doing this in the compiler scope, this mutability. Let's have it also as an argument, I guess. I'm not sure here. Let's not do it here for now. Mutability. Let's just say that it is nested. Maybe to do. It's the mutability here. This method takes 3 arguments, but 2 arguments were supplied. So there you go. We're injecting the binding. But this is binding. This is the this is wrong. Like, this is not really something that should be the same as Binding mutability. Place mutability. New new binding mutable. So bindings, their mutability is just a binary, whether it's mutable or not. Or maybe I should just have binding mutable. This should instead be called mutability, and instead of just having a boolean, we should actually have the mutability here fully. Maybe we will have more than just two options. Who knows? So compiler bindings mutability would be mutability. Probably we should just rename this to mutability then, right? So by default it's mutability read-only, I guess. Okay, compiler mutability here would be mutability mutable. Have a mutable pattern. Okay, it's matched. Fine. Okay, now here, what is this? A native function. Insert an owned place. Self map values. I feel like this should not be done here, but this state, no, mutability nested here. A variant. This is a function hashmap get. So yeah, we have an owned place. It owns a reference, but this is basically a new thing. Owned mutability nested. Maybe there should be just a separate constructor for these. There's more. This is a list push. List push, also mutability nested. What about this? No, that's the same thing. Pattern match. Yes, over here I'm doing the pattern matching, and now since I have a binding and I have a value and I know its value now the mutability of this is binding mutability, right? There you go. If I say here a match, this is matches. We do the same thing, binding dot mutability. This is the same thing, binding mutability. It's weird. It's like, feels like we have copy pasta here. That garbage window pop up looks bad for Linux. Which one? What is garbage window pop up? Windows pop up. Activate Linux. Well, I cannot get rid of it. I don't have the money. Right. What is this? Insert uninitialized. This is just let. Yeah. This is let without values. So we shall say that mutability is binding mutability. Just collect the bindings there. In the pattern. Yeah. Makes sense. And we have this into value rusty. Rusty value. Okay, it's just constructing a vec. Yeah, on place new value nested mutability. Mm, mm. Private type place deref. Yeah, so like place owned place is derefing into this. What about place ref? Is place ref also derefing? Or place read guard? Not for the place ref itself. Sure, let's have it public for now. I don't know. Okay, so it should compile now. Is it going to work? Am I even checking for mutability yet? I just initialized the field of the place mutability. That's all I did, right? No, I am checking. Check can mutate. There you go. Right. Assign new value is also weird. Okay, there we go. Place is read only. Where? Source value 53. Close spike. Into values, tuples. Place into value. Unwrap, take values. Take value is right. Oh, because right, yeah, okay. Right is what is checking for mutability. Yeah. So this is like, this is wrong, right? In order to take a value, it does not need to be mutable. That's right. So these checks are not correct actually right now. I mean, I guess it's because this check for mutability should be, yeah, it should be over here, right? If I'm read, check, and read, this is not necessary. This is implementation detail. This is the public API. If I want to read value, then I need to check that it's going to be read. If I want to write value, I need to check that it's going to mutate. If I want to take a value, like it should be check can take. Let's have that. Quick function check. I don't know. I mean, it's the same thing. Let's do can read. Can read is just always true right now. So like assigning, I guess cloning also. Cloning means that I can read it, right? Mutability check can read. Assigning. So assigning a new value, this one over here, it depends. It depends on the current state, right? State. State is this, right? So match state. If it's either uninitialized, occupied, or moved out. Can you move a value back in Rust? Probably not, right? Does that make sense? Play Rust lang. So if we have something like let foo is foo, right? Where we have struct foo, so it's not copy, right? And then I say let underscore is foo, and I say foo is foo. Can I do that? Probably not. Cannot assign twice to a mutable value. Yeah. So even although it has been moved out, we should not be able to do that. I think that makes sense. So we only check. So if it is uninitialized, then I allow assigning, right? Uninitialized, then we just don't care. But if it is occupied or moved out, then I should check that we can mutate the thing. Okay, so this works now, right? Here's the code, right? So I can try removing this mute keyword, right? And run this again, and it will say places read only. So when I'm trying to evaluate this is being checked at runtime, not at compile time for now, right? But we see that this is trying to mutate the variable x, and it is read only, so it should not work. There you go. So we require mutable keyword here. Okay. This should also be done at compile time, right? This should also be done at compile time. But it also means that, like, especially for like not initialized things, whether it's like initialized for the first time or not, would be compile time is more difficult. Compile time is more difficult because we want to have something like this: let x, and then we say like if true, then x is 1, else x is 2, right? So like this is supposed to work. This is not mutating, this is initializing the variable, right? But whether a variable is initialized at compile time, I would need to I would need to as soon as we like exit this scope, we need to like cancel something. All right, let's not worry about compile time checks yet. But there is this other thing, right? So now this is mutable, but this over here is not mutable. So since foo is not mutable, we have a reference to x. We have a reference to x. We have a reference to x. Boom. Let mut foo is foo. Let x be mutable foo. 1, 2, 3. X dot 0 is star x0 is foo. Wait, so wait, hold on, this works because this is a mutable reference actually. So this is supposed to work then, right? It's supposed to work. No, it depends. It depends. This is more like moving the reference out. If I say over here dbgx1, this is no, this is still compiling. If I say dbgx0 though, derive debug. If I say dbgx, Wait, why did I think that it should not compile? If this is not marked as mutable? Am I thinking of something else? No. Yeah, this is not supposed to work, right? Wait, hold on. How is this working? Hold on. If this is not mutable, I can construct a reference to it, right? X is reference to X. Maybe it's because it's not a reference. That's why. Yes, there you go. Like, if this is behind a reference, then I cannot mutate foo. If it's not behind a reference, then it's different. Hmm. Let y be reference to x. This also is supposed to not work. Or this is still working. What if I do dbgy here? Yeah, we cannot assign because it's borrowed. So the rule is not that this itself, so this place itself is not mutable, right? But I guess this over here is mutable because it's behind a mutable reference, right? But behind a mutable reference, we can get this is only mutable. The thing behind a mutable reference is if the path to this is unique, basically, right? That's the idea. If the path is unique, so we are not sharing it with anyone else. This could be inside a nested thing. So this example that I have should work. What should not work if I have the new reference, a reference to foo, right? Also, if I have a reference to just foo.a, right? That would be the same thing. If y is a reference to x.foo, so over here cannot assign to x.foo because it is borrowed. X.foo is borrowed because the entirety of x is borrowed. This would be like the same error, right? Yeah. So wait a second. Wait a second. Wait a second. I wanted to make my mutability different. Specifically when I say mutable X, this would introduce two things. It would introduce the X, the place itself, and then the access to that place that is mutable, right? So we have like it's something like this. We have X access to X of type access, like mutable access to X. We have this thing here, and then when we do a plus equal, since we want to mutate this place, we need to have the access, mutable access in scope with the context system, right? So in this case, we would even make this code compile, right? Um, mm, mm, mm. I didn't want to get into the borrow checker today, though. Maybe just what I already implemented is good enough. But this means that this example works, right? But maybe this should not work. Then we have like a list. We have a list of 1, 2, 3, you know, list of integers. We have a list of integers, supercuber, high. And we have a list get from A, the element at index 1, right? Element is this. So this is, oh wait, hold on, it has been moved out. Oh, because I debugged that. Yeah. When I debug, I move. Sure, so this is a reference to the second element, 2, right? And then if I say element is like equal to 5, right? dbga again. So I have mutated this thing, and now we have the list of 153, even although the list was not declared as mutable, right? Because this is the inner place inside of the structure. So like similar to this over here. Similar to this thing. Or maybe it's not similar. So what's the difference? How do I know that something is supposed to be mutable or not? Here. So this is a place that has the nested mutability. That's what we called it. All right. Yeah, but I don't get the where it came from, right? I guess this is a property of a reference, maybe. Maybe it's a property of a reference. So we have place reference, right? Ah, shit. We have place reference. A place reference is just a reference to a place, but I guess it's not just a reference to a place. But it should also know whether I can mutate that place that I'm referring to, right? Is it a mutable reference or a not mutable reference? Can I mutate it? Is that what I want? New temporary. Some expression result for place ref. In Rust is solved by not being able to create a mutable reference from a shared reference. Yeah. Cast is not distinguishing the two right now, but it's supposed to be a little bit different. I think we are like the mutability. I wanted it to be a little bit different than in Rust, but I think it should be like as in Rust plus the thing on top. It's not just being able to create. You can create the mutable reference. But then you cannot modify it still, even although you have a mutable reference. You are not always allowed to modify the thing behind the reference, because the mutable reference itself is behind a shared reference. You know, weird. So my thoughts about the borrow checker were, I don't know if you were here when I was explaining this. There is a paper called Ghost Cell, or maybe you had just seen this before. There is a ghost cell separating permissions from data in Rust. So this is the idea. You was too lazy to read it. Don't worry about reading it, but I'll just tell you quickly what it is. You separate the data from permission to access the data, right? So basically, what is a reference in Rust? What is a reference in Rust? We have a reference, right? Which basically is two things at the same time. It's the pointer, which is the pointer to some data, right? A reference t, right? This is just the reference to t. You know, this is a pointer plus it's the like the access, which is the read access, basically to this specific pointer, right? So you cannot really express this in the Rust type system, but this read access, right? So it's like a zero-sized type read access. So it only exists at compile time. Basically, you have read access, you have write access, right? So reference is basically same as a pointer, but you have this zero-sized thing, which specifies that you can read this pointer, right? And then when you have a mutable reference to t, this is the same thing as having a pointer. I don't know, like all of these can be like mutable, whatever, right? But this has the write access inside. So let's just say over here, we have pointer t, right? We have pointer to t. So a reference is a pointer plus read access, and a mutable reference is a pointer plus write access, right? So when you have the pointer t, right? So this is inside just like mutable pointer, like in C, right? I guess. And then you have implement pointer t, right? So basically, if you want to actually have the if you want to actually read the value behind the pointer, then you need access to the pointer itself, right? But you also need the access, which is read access. And then out of this, you can construct a reference to t. And this inside would be like just unsafe star self 0, right? Something like this, unsafe reference to star self 0. And then similarly to that, you have a write access. Write access takes mut and returns mut t. And then you do this. So if we have this API, can I make this to be on the side or something? There we go. So like we have this API, right? We have this API. So we so instead of saying that I'm constructing a mutable reference to foo here, right? How do I say it? So basically, you know, we have the foo, right? So when I say that we have a mutable foo variable, this is the same as having foo pointer. Which is pointer mat foo as star mat foo, right? This is how we like basically, this is what we compile it down to, right? So a mutable thing basically has a pointer to this variable on the stack, I guess. Kind of. And then we also have foo access. Since this is mutable, this should be just write access, right? So we have a write access to foo. We also, I guess, should have implement deref for write access. So if we have write access, we automatically have read access, right? Type target is read access. So function deref self read access. Just have read access like this. Some people are too poor for a license, don't judge. Yeah. Yeah, so this, right? So now we are supposed to basically never use foo directly, right? So if I want to mutate foo, then I will say something like foo pointer write foo access is equal to foo, you know, something like this. And then I would say also dbg for example foo pointer dot read from foo access. I don't know if this code makes sense to you, but it's kind of how it works. std ops. And yeah, and then we'll have like struct foo here in the example itself. Right, so this can I borrow foo access? Yeah, this is mutable, sure. So why is this good? Why is this good, right? The reason is that Can I have like some empty lines in the bottom? Thank you. So the reason is that if you have this, so this is basically in code of cast is just literally same as foo is equal to foo, right? This is just mutating the variable. This is what it compiles down to, basically. And this is just dbg foo, right? This is reading it or something, whatever. This is verbose because it's like low level. So why is this good? It's good is because we can have because like the pointer itself can be shared, right? For example, we can have a thing like we can have, let's have this simple counter example, something that doesn't work in Rust, right? Let's have a simple counter example which does not work in Rust. Counter state is 0. So counter pointer is this, and counter access is right access. I have mutable counter state. It's mutable pointer. There we go. There we go. There we go. So what we want is we want to have the two closures. One is increasing and one is decreasing, right? The code that doesn't compile in Rust normally. So what we want is we want to say, you know, like counter a state plus equal 1, and we want to say counter state plus minus equal 1, right? Like this. Let's just comment this out for now, because this is not going to work. I guess it works if I never call these functions. If I call inc and then if I call deck. Let's try this. Yeah, there we go. See, we cannot borrow counter state as mutable more than one at a time, right? This is the problem that we're trying to solve here. Why is this code not compiling? Right? So instead, we split this variable into two variables, the pointer and the access, right? So we say that in order to modify the state, we instead say that we take the pointer, we take the pointer and then we mutate it, right? But in order to mutate, we need access, right? Access. Access plus equal 1. And then we mutate here, and we like minus equal 1. So where is this access coming from, though? So the access is going to come from the arguments. It's like very similar to... I mean, we could just like have the mutable reference itself passed. I guess, right? So this is not a very good example. But yeah, basically we take the right access as argument here instead. And then this just compiles and works, right? Counter access. Like this. So this just works. Although I guess we could just have the counter state directly, so maybe this is not a very good example. What would be a better example? I guess their example is something like a linked list. Something that you cannot do in Rust. Right? Like a doubly linked list, for example, would be a better example. Like, because you have this pointer, which is separated from the actual permission, you can still use this pointer in other places, right? This closure, it's capturing the pointer, but it's not capturing the access. You know? So we can have something else pointing to the same state still. Right? Yeah, this is not the best example. How difficult would it be to make this example with a linked list? What is their API even? Instead of borrowing enforced by static checking is recorded by having a single instance of the access. So you have like the borrow check-in not on the data itself, but on the access object, right? Access object is a zero-sized thing. And then the pointer is just a pointer. The pointer can be shared freely. The access object is something that is the access object is something that is like using the normal Rust rules. I'm just trying to like think of a good example. I guess like we need to go to the linked list. Doubly linked list. Don't have the I mean, you in generally you cannot create a link to like the data structure that has like pointers all over the place, right? Like that's why you resort to using indices when you want like a graph instead of references, right? I guess also this can be simplified. I think we can just say that it is access, you know, but this one requires a read-only access, and this one requires a write access. So that's what we do, I think. The reference AT is that. Ref much is a right. I guess this is how you do it easier. And then over here, our access is a mutable access because this is a mutable variable. That's what we do. Huh? Whatever. Okay. Yeah, I guess let's try to have the thing. Let's also have this inside a macro. Macro rules let I don't know, ghost let so we have x ident is equal to value, which is expression. This would be let mut most data is value, and then we say let x-axis, x pointer and x-axis, right? We need to like provide the two identifiers here. Let x pointer is pointer at data as star mat underscore. Let x axis is axis like this. And then if we have a mut here, and then we just change this to a mutable axis. That's the only difference, right? So yeah, just so we can like write the code, right? We just say ghost let mut counter pointer counter axis is 0, right? Rules. I mean, this is fine. Yes. This means that I just like I hide this data variable completely, I guess. Expected semicolon. Do we need semicolons here? It's been a while since I wrote a macro. I guess there you go. Hello, I have absolutely no clue how code works. Hi. Yeah, we're trying to figure it out here. How code works. So there you go. We just say let mutable, and then this introduces us two variables, the pointer itself and the axis, right? And then we use it something like this, which is supposed to be behind a syntax sugar. And this also is supposed to, like, we are not supposed to write this. So like in cast, it would be just normal closures, which don't compile in Rust, but we want it to be compiled basically, right? But in terms of like a better example, I mean, I don't know. Maybe this is a good enough of example. Like this is just doesn't compile in Rust, and it's supposed to compile, right? Isn't that a good enough example already? Maybe. But I guess the reason, the question is then, like, why don't I just then in this case pass the reference as an argument always? Well, I guess, okay, I guess the reason is that this is going to be compiled down to 0, right? This is a 0 size type, right? Obviously, you can mimic this API with just something like this, right? Let mut counter is 0, and then you say like inc is x mut I32, right? X plus equal 1, and then you have dec, which is this minus equal 1, right? So like, what is the advantage of this approach, I guess, is the question. So we say inc counter, and we say dec counter, right? So the difference between these two is that this becomes a freestanding function. It doesn't capture our variable, right? And we pass it as an argument always. Right? While in this case, this is a zero size type, so the function is going to be compiled as a function taking actually 0 arguments because this is 0 size. So we can completely, this is only existing at compile time. So it's just a normal function, right? That's the difference here. Diego Dev, hello. This is the difference, right? And then can you how can you check that it is true? How can I check that what is true? That it compiles down to 0. I guess we can do assembly, right? But I guess we do release. Although it's probably like we'll inline it too. Main. Start. Probably like optimizes it too much. I mean, will I be able to see it? Can we see something else? Maybe I don't know. If we do the MIR, is it showing it still? Yeah, the zero size type still exists in MIR. We do want assembly. Did I try sudo activate Linux? No, I think it's going to work. Wait, you guys know my password? I can't do that if I don't know the password, right? Rep. Playground main. Call pointer right. Hold on a second. How do you read this? Ink deck. Is that Niri? What do you mean? No, this is just the assembly. Oh, maybe we can read like WebAssembly easier. Hold on, maybe WebAssembly would be easier to read. I don't know. What is this? Maybe not. Hold on. I'm supposed to export this start or something. No? Memory 16. Looks like octet stream debug. This is just debug information, right? Which doesn't matter. Where's the actual code that I get compiled? I don't know. ASM. Let's try reading assembly again. Where is the result? Why is the result hidden to me? This playground, is it even working? Neri is a Wayland compositor. Yeah, no, I'm not using Neri. This is Hyperland, I guess. The question. I said show assembly. Where is my assembly? It's literally not here. Look at this result. And there is nothing there. Hello? Cannot establish a connection to the WebSocket. Okay, maybe that's why. Can we have... Oh, wait a second. Wait, why is there a crate type cdlib? I did not do that. Right? What's the other, like, show assembly, Rust. What's the other website that is doing it? Godbolt. See. Rust. Maybe it's better to see it here. No assembly to display, 5 lines filtered. What do you mean? What do you mean no assembly to display? Or is it trying to do it in release option? DBG pointer read. For access. Wait, what do you mean no assembly to display? 5 lines filters. What's the lines? Used labels. I guess they were just filtering out because they were unused or something. No. It just compiles down to 0 or what? Function main is never used. I mean, it's because it's never used. Okay. Compiler flags. Shit. Why did you ask this question? This is a difficult question. How do I even do Rust C help? How do I do debug? We just do -0 or something. Compilation failed. Click the output. Unexpected option 0. Like, what's the default thing here? Do we just compile? It says some warnings. The problem is main function is never used, so it gets optimized. But I produce a binary with Rust C. Okay, fine. You know what? We can do this. We can do this. A source, a bin, test, bin, ghost test, rs. Let's just do this locally then. Let's just do this locally, right? We have this function. Let's comment this out, and then we do Rust C. Rust C. Emit ASM source bin ghost cell. All right. Where is it emitting it? Is it in the target now? V. Verbis. VVV. Help. Thetis for Titis. Thank you for the sub. How to make it super verbose? Use verbose output. It literally didn't add any output. Oh, this is the thing, right? Ghost test.s. This is my assembly. There you go. There you go. There you go. There you go. Okay, we have assembly. GCC. Ghost test. CGU. This is more that I saw in the playground. Is that Emacs? This is Vim, NeoVim. Neovide. Rust A personality. Alright, where's my main? How do you read assembly? Hold on, it's been a while since I read any assembly. Is this just the main over here? So I'm calling... No, this is calling the start internal. Right? Start internal. Okay. Where is the start internal? Like, am I not supposed to... Like, is this not supposed to be defined here? It was there. Main. There we go. This is the main, right? This is the main. Hold on, there's main 17 and then there's main 28. How are they different? You just came from an interview, you walked 10,000 steps. Wait. They made you walk on the interview? Are you trying to get hired as a, like, a professional walker? This over here, right? This is the closure inside our main, which we call twice. This is calling inc, and this is calling deck, right? And before that, we have the leak. What is the leak? Leak assembly. What kind of assembly is that even? Is that from x86? I never used a leak thing. Where's the documentation? What does leak stand for? Load effective address into this, right? So I guess it is actually putting the reference on the stack here for the zero-sized types. Is that it? RDI, RSI. Why is it loading two things then? Load effective address. Why is it two references? It is two references because first reference is a reference to the closure capture environment, and the second reference is a reference to the to this like access object, right? We need two references to call this function. This is a closure, it has an environment, a capture, and an argument. These are my two arguments, right? So I guess like it's not compiled out, at least if we do it without optimizations. What if I do this with optimizations, right? Then it's a little bit smaller. So here's my main, right? Call Q. Leak call Q. How can I make sure that the function is not inlined? In Rust, that a closure is not inlined. Rust prevent closure from lining. Closure inlining. We just do inline never, right? Or or something. Can I just do that? Inline never. Attribute should be applied to a function or closure. Yeah. So we do inline never. Like so. Attributes on expressions are experimental. Wait, what? You literally said that I should be able to do that. There's no way to ensure that. Inline never is a strong suggestion. Okay, but I mean, hopefully we'll just see it, right? Anyway, I need to compile this with nightly Rust. Okay, nix run. How do we even do that? We need to download the nightly Rust. I don't know. Can I not try it? And like, what's wrong with the playground though? Show assembly, please. Oh, there you go. Now it wants to show me assembly. Maybe I was like compiling too much and it like rate limited me, but it didn't show me the error that it was rate limiting me. Maybe that's what happened. Let's try release. Let's try release, but I will do inline never here, and I will do inline never here, and we do nightly. Whatever, right? Attributes, yeah, so we need to do feature, statement, expression, attributes. Yes. And so there we go. We have main. Wait, this is main? Full queue. Rip. Oh, this is playground main is what we want, right? Playground main. So yeah, we have two playground main closures, right? There we go. 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 We have two closures. What is move queue? So we have like RDI is a like what is this a register which is holding the pointer to the to something, right? To the closure environment, I would assume. And then like what is this? We are reading the thing behind the closure and we are putting it into the RAX register, right? So this is just a closure environment, I think, right? Yeah, there we go. Look at this. So we have playground. So we call two closures here, right? And we only move a single argument here now instead of two, which was what I saw in the debug assembly. So this is only one argument. We still need one argument, which is the closure environment, the variables that we capture, right? So that's the pointer to the captured environment. And not two arguments now, like before. So it's all correct, right? Over here, wait. It would be nice if I knew how to like do this manually though. At some point I will want to inspect the assembly, right? You want to play Linkside at the moment? You're bored of Noita? Linkside or roguelike when? Spike, how do we quickly do the nightly Rust? Can I quickly do Rust C, but nightly from the Nix packages? Probably not, right? Probably not very quickly. I can change my entire flake using not the stable one. You should use rust up. I guess I could do rust up real quickly. Yeah, I'm using Nyx though, so I don't do the rust up. You haven't ever figured out how to get the Cargo Plus nightly command work on NixOS? Rust up doesn't work well. Let's see. Linux shell, Nix packages, rust up. We can do that. Wait, rust up. Nix shell, not run. Never had issues with rust up. No, I think rust up should work. It's just like rust up install nightly. Let's do this. Like, I'm pretty sure it's going to like it's working on NixOS too. It would be nice though if I could just have used the features on stable Rust sometimes. So how do we do Rust up? Rust up. Like, how do I run something with Rust? Rust up run. Rust up run. Rust C version. Run Rust C. Toolchain Rust C. Rust up run nightly. Rust C version. Is that how you use it? There we go. Right. So we have now Rust C source. We do emit assembly source bin ghost test like this. Okay, and then we can do this with optimizations, and we can also now over here actually do inline never. Right. And we need what feature statement? This one. Over here. Play main. Yeah, it's called ghost test main. There we go, there we go, there we go, there we go. So this over here is going to be release, right? And then we have the same but without that. Be split. Pick window. A. No. Main. Go cell main. So this is what it compiles down to in debug mode, and this over here is the release mode. Ghost test main. Right? Like so. So we have these two closures over here. The closure is being called, and over here the closure is being called. So the difference is that the closure is being called with two arguments, with two registers, RDI and RSI, in debug mode, and in release mode, the zero-sized type is getting optimized away completely. Right? So it is being optimized as it should. Okay. I don't know, like if this is very convincing though for like wanting the ghost cells, like this example once again, right? I guess we can. I guess we can check this. That's what we can check. So what's the difference between this code? What's the difference between this code? Let's have ghost here, right? I'm just going to instead in this code say that this is our main, right? So this is how we do it without the ghost cell, basically, just like so. So let's compile that again and see the difference. Main. Yeah, I need to get rid of the inlining. Hold on. We need over here to do the same thing. Line never. We need to do here. Line never. I mean, maybe in this case it will like compile to the same thing because like this closure gets converted into just a function, right? It doesn't have the captured context anymore. So maybe it's not. I wasn't even like writing the thing and it still didn't get optimized. Okay. Maybe I don't need to. Main. No, in this case it like gets optimized completely still. What do we want? We want to like write it, dbg. Is that how we do it? Oh, there we go. There we go. We have two closures. Yeah, we have two closures. They're still like being called with one argument. Yeah. So like in this specific example, it's not really much different. I think it's just like in a little bit different offsets. But other than that, the code is the same kind of. All right, well now I need to like come up with a better explanation why we need this, right? So the better explanation, like because I could just make this to be like an implicit argument, right? So the code that we want to write and we want to compile is just this, right? We want to have a counter. We want to have a counter, and we want to have this as captured thing. That's what we want. And we don't want to pass this explicitly, right? That's how we want the code to look like. And this is not going to compile. Because it's because it's capturing the variable twice. Cannot borrow as mutable more than one at a time. Right, so you solve this issue with instead of capturing, pass it as an argument, right? That's how you solve it. Or you solve it with a ghost cell with capturing the pointer, but then having as an argument the access, right? But yeah, maybe this is just too simple of an example We want a structure that is pointing back and forth. Let's have a simple example, like a linked list. Let's have like a linked list, but which is let's have a linked list. Let's do this in this one, I guess. Here. And let's get rid of all of that now. Let's have a linked list, but a very simple one, where we have just two elements, right? Let's have this. So what we want... let's see, struct foo, right? Struct foo. I want to have a reference to another thing, right? So like the other one is I guess I would need it to be optional reference to foo. You see how we need the lifetime here also, right? So we need a lifetime. Like we literally cannot even do that, right? So A is foo, where other one is none, and then we do B is foo, other one is some A, right? And then you do A dot other one is some B, right? Obviously you cannot do this, right? Cannot mutate immutable variable A. Even if I make this mutable, you will say that cannot assign because it's mutable, right? So how do we make this code work? So instead of doing that, we just say that that A is we say ghostlet. We say ghostlet. We have mutable thing because we will want to like point this to the other one. We cannot initialize them at the same time. Although I think in cast I want it to be able to be done at the same time, like make self-referential types, I guess, right? So we have a pointer and a axis is foo, where other one is none, right? And we also change this declaration to be different. We just say struct foo, where other one is optional. So over here we just say pointer to foo, you know. So we just have pointer. Right? We have this. Then we say. Then we also say so like B does not need to be mutable. We just say other one is some a pointer, right? Can I make this copy? Because this should be copy. Clone. This is just Clippy. Yeah. Hold on. Allow Clippy all. Don't worry about it. Allow things. So we have this, and then we say a pointer right with a axis dot other one is some b pointer, right? So and just like this, use of moved value a pointer b pointer. Wait, I derived the copy. Move occurs a pager R which does not implement the copy trait. It's literally there. Hello there. Oh, it's because T itself is not copy. Yeah. Okay. I guess this is just a thing. Yeah. It's because the deriving is not working properly. We need to do implement T clone for ptrt. Implement T copy for T for ptrt. Wait, can I even do that in Rust? I guess. There we go. Cargo on bin ghost cell. Call it ghost test, sure. Wait, what do you mean cleaning? Why is it cleaning? It's deleting my entire target folder. Why is it doing that? Wait, hold on. Is it because is this because of which cargo? Is it because from the Rust tab? It's because I installed Rust tab. Stupid thing. Now it cleaned the entire thing. We need to recompile everything from scratch. Or do we not? We actually don't. Alright. Alright, so this works. Is this... When you exit Nix shell? Yeah. I just exited the Nix shell. So I uninstalled Rust tab basically, and it just works now. Some advice to start using Vim as main editor? What do you mean, advice to use Vim? My advice would be not to use Vim. If you want to use Vim, then use it, but like, why do you want it? Not needed. Okay, so is this a good example? Is this a better example, right? We basically construct the thing, right? This is not like the full example. This is not exactly Ghost Cell, because I can use the access that is assigned to B to access the object A, which is which is something that like Ghost Cell is preventing with like the branding of using lifetimes, you know, because I can literally do this aptr write B access, right? Especially like if I make this mutable, I guess this would be possible, right? But this is supposed to not compile, right? I'm supposed to only be able to mutate the A using B access. So in order for that to work, I don't know, maybe we can do that. Well, I mean, we kind of can do that. We would say something like ghost let as a function. So we have like some value of type T, right? And then we have the function impl fn1s, which would be using the pointer, right? A pointer to T and access. Access. So now we just need these two things to be like branded together, which would be tied to a lifetime. So this is a lifetime on the access object, you know, and this is a lifetime, but it's a different lifetime than the lifetime of like the object itself. This is just for branding. So we make sure that we're using the proper access by saying that the brand is the same. The lifetime is the same, like so. Get rid of this. Just say GhostLed is a normal function. Like so. And this function should be generic over this lifetime, so this should be impl for a. Alright, it should work for any lifetime. That's how we get basically an anonymous lifetime. So instead of saying GhostLed, we say this, GhostLed. So I initialize the data, foo other one is none, right? And then over here we get as a result the pointer and access to a. These are tied with a lifetime, right? Together, and we have the same thing, right? We have did I remove the I removed it. Struct foo a other one option pointer a wait, I don't think I can even do that, can I? There should be like a different lifetime, foo b. But then we have like two arguments. This is weird. Hold on. Ooh. How do they solve it actually? I'm not sure. We can we can try seeing it in the paper. But yeah, it would be this GhostLed and this, then this GhostLed, when foo other one is some a pointer. And then we get b pointer and b access. And then we have this. A pointer write using b access. This is basically the same code. It gets a little bit more nesting, right? Because we don't have language support for it. But I think I cannot do that here. Let's do I guess what I can do is just have pointers untyped for now. Have a little bit more of yeah, let's just do this. Let's see, void. Let's do that. Then I can just derive copy clone. Town. And I will have phantom data, I guess. Okay. Phantom data is not needed. Phantom data. And over here it should be mutable, so we don't do that. Hello, Brainoid. Pointer T. Yeah, so we just have pointer. It's already implemented. Then, so yeah, instead we just say that pointer, we just need to read T. If we have the access with A, we can read that. Self as star not T. Yeah. This is like unsafe, but it's fine. Is this actually safe here, right? Yeah, this should get this thing. Yeah, like we don't get the type safety of this though now, which is weird. So we just have a pointer and access to use that pointer. We just have untyped pointers, basically. Right? Okay. So we basically call so yeah, we just initialize the like the variable itself. Like data is value, right? And then we just call function f with pointer, having the pointer here, mat data as star mat t as star mat c void, right? That's our pointer, and then access would be mutable access with phantom data, and over here we also have phantom data. Downtown bot musty, hello. Right. Ooh. So there we go. This now doesn't compile because I'm trying to write to the pointer of A using the access that gives me access to B, but this is going to compile because like they are tied with a lifetime. So this makes it a little bit like annoying, obviously, right? So yeah. But the idea is that if we have language support for that, then it will just look like normal code, just like this, and it will still compile. So we can create this self-referential like structures like this. Right? Let's take a look. Why could I not implement the generic pointer? Why did I type arrays? Why did I type arrays here? Maybe like, yeah, there you go. Implementing doubly linked lists with the ghost cell. So you have the node structure. You have arena ID and T. Option node ren arena ID. Oh, maybe they are using the same IDs for these things. But region-based memory management with arenas. Does it mean that we cannot get access to like multiple nodes at the same time? Is that what they mean here? Like in their implementation? They call it ghost token. I called these access. So we have a node, data T arena is a typed arena. Node arena IDT. So like it's all the same IDs. ID is basically like this branding lifetime that we used here. They call this thing ID. Yeah, I guess in order to let's try again. If I have T, we have mutable pointer to T, then this, yeah, let's try this still. So the access object only needs the ID to be the same, obviously, right? We just do that. ID T. So ghostlet would be pointer to T access like this. We do that. right? Well, I mean, the problem is that I want to create the two things at the same time. So one of them should be made with a ghostlet and the other one should have the same ID. Like the only, like we have the self-referential like structure like this, and I'm only supposed to be able to like modify either A or B, but not like at the same time kind of thing, right? So we have who, so we have a pointer to this over here is ID, right? So the ID of this is the same. We do that, right? We do that. So the question is, how do I over here we say use of moved value? Yeah. So the inner one should be not done with a ghostlet. How do we do that? We say oh, it's just value moved here. Wait, I just did the same problem, the same mistake again. So like impl t clone for ptrt, because it doesn't work otherwise. Impl t copy for ptrt. Maybe this just works. Let's see. No, they say that lifetime does not live long enough, because this is a new lifetime. Yeah. Well, this is supposed to be not a new lifetime. So I guess I will say that this should be like inlined. Maybe we can have something similar. So ghostlet with existing ID, I guess, is what we want. So I want to have a ID. So this should work for all IDs. Wait, can I not rename this lifetime? No references found. Just call this ID. Right, so this with existing IDs would be, instead of this being a generic function, we just do it like that. Which means that it doesn't introduce a new ID. But it also means ghostlet with existing ID. Lifetime may not live long enough. I think we just generate a new pointer and the access is going to be the same, right? Because we have the same access object, basically. Right? They still say lifetime is not living long enough. Recurrent occurs because of the pointer, which takes the makes the generic argument invariant. Wait, why a pointer is making the generic argument invariant? This is wrong. The argument should be not invariant. The pointer itself. No, hold on, no. Yeah, it is supposed to be invariant over ID. Right? Because the ID should not be changed. Yeah. But must endure. Hello. Lifetime may not live long enough. Pointer. Pointer. Other one is this pointer. Lifetime may not live long enough. Destruct is invariant over the parameter t. Invariant over the parameter t. Yes. So what? So what? TID? I don't think that's the issue. Pointer ID. Maybe like I need this to be IDT. Well, I mean, it was already specified here. Struct is invariant over the parameter t. So the parameter t is this one. Your hairstyle turned you into a proper Russian mafia member. Yeah. Maybe, I don't know. What's the difference between a Russian mafia and like the other mafias? Though. All right. Why am I even doing this right now? Who started this? Why am I doing this right now? Is this even useful? We are doing just an exercise, basically, to implement the ghost cell in Rust ourselves, right? Just to understand it a little bit more, maybe. Why does this not work? The hairstyle. I'm pretty sure that in the other movies or about mafia, this hairstyle was being used not only by Russians. The top hat and a trench coat to be accepted into Italian mafia, and a trusty machete to get into the Mexican cartel. All right. A pointer. So this has the type pointer with a full lifetime 2. Yeah, because I cannot like refer to this ID yet. That's why. That is actually why. Hold on. I understand what's happening here. I understand what is happening, I think. Like, we already specify the type of the ID here when I'm constructing this foo, right? But this ID should be the ID that I only get here from the inside of this thing. So maybe I need a ghost let with just some unit data so that we get this and like this is a way for us to generate a new ID. We can only generate a new ID inside a function like this. So I don't care about the pointer here, but we have the access, right? So we have this access object, which is basically the same, the thing, right? Let's just have like the actual function, so like so that I can describe the type of it, because you cannot type annotate the closures too well. So this is the function f. It will have the pointer a unit, right? That's what we want. And it will have access, which is access a, right? The notable reference to access a. This is called ID, by the way. Right? So we do function is expected to take 2 arguments, but it takes 3 arguments. There we go. Right, so we just do a ghost let f, and inside of this we're going to use this existing ID. I think that's how we do it. Ghost let with existing ID, right? Which doesn't give me the this thing anymore. We just have the access object originally, like this, and there you go. It compiles, right? So what we do here, this is literally just the alternative code for this code, which just doesn't work, right? We want to construct an object, construct like another object pointing to the first one, and then point the first one to the second one, so that we have like recursive references. This is what is normally not doable in Rust, but with this API that we just have created, it is possible now. But the like, even though there is this unsafe here, this is actually like properly safe, right? Because we can only access this pointer if we have if we have the access. So like access, a reference to access is same as having like the normal reference to the data. But now we have split the data and the access to the data into separate things. So we use the borrow checker only on the access object, and this is going to be compiled down to nothing because this is just a zero size type. It's just phantom data inside, and that's it, right? Yeah. But this is ugly without compiler support, which I guess is why this is not being used a lot. Is anyone actually using the ghost cell or something? How would I find it even? Ghost cell Rust. Like, I want to, I guess we can take this crate and see maybe who depends on it. Right, dependents. There's token cell, a more convenient ghost cell, and then there's alternator, tool for building effect system. Interesting. I want to look at that. There's the token cell. The slide provides an alternative to ghost cell, which uses concrete types instead of live types for branding. This allows for more convenient usage, where cells and tokens can be constructed independently with the same compile time guarantees and the ghost cell. The trade-off for this arguably is arguably more convenient usage and arguably easier to understand branding method is that tokens, while zero-sized is made correctly, must be guaranteed to be constructible only if no other instance exists. This provides the generate token macro. Yeah, which can be used to constructing using token trait new. And kernel trait for Xeno. What is Xeno? Eclipse Xeno. Zero overhead, pub, sub, store, query, and compute. Unifies data in motions, data in rest, and computations. It carefully blends traditional pub sub with geo-distributed storages, queries, and computations while retaining a level time expense efficiency that is beyond any of the mainstream stacks. Some proper marketing text. So what, like, what are they using it for? Just so that they don't use unsafe, like that's the use case for the ghost cell, right? You want to make fast code, but you don't want to make an accident mistake. Your unsafe code. I don't know where to look though. Is there any other There is no way no one else is using it. Tools for building effect system-like functionality by abusing async. Amazing. There is not much here. Sleeping future. Alright, we were abusing async at some point too. What is this? Barbara wants to use Go Cell like cell borrowing. Who's Barbara? White likes instantly checked cell borrowing. Cell in Rust terminology refers to types like cell or ref cells that enable interior mutability. Modifying or mutably borrowing stuff even when you only got an immutable reference to it. Yeah, basically, this is what Go Cell is allowing, right? It's like you only have an immutable reference to it, but you can still mutate it and it's still safe. Right? Yeah, ref cell is checking at runtime. Go Cell is checking at compile time. This technique can be reinvented at least 2-3 times. Maybe there's like some more. For the investigation. The stacker runtime. What is stacker? Uses runtime makes use of QCell based statically checked cell borrowing. It uses it to get zero cost access to actors, guaranteeing at compile time that no actor can access any other actor's state. Wonders whether there is a way this can be made to work. For example, could the compiler derive all those IDs annotations automatically? That's literally what I'm trying to do, right? That's my idea. I want this to be done on the compiler level. A stacker. Stacker is designed to be a layer on top of whatever event loop the user prefers to use. Rust compile time checks and optimizations. Lightweight, low-level, single-threaded actor runtime for Rust. This is work group async from Rust-Lang GitHub.io. Does this mean that this is submitted stories? What is this even? What is this even? This is async work group of Rust. So is this something official for Rust? Example 1, accessing object shared outside of the runtime. In this minimized example of code to interface a stream to code outside of the async await system, the buffer has to be accessible from both the stream and outside code, so it handled as an RC ref cell. Yeah, so like you've seen this code a lot probably, right? Stream pipe. So you do just a RC ref cell, so that you do that, right? We statically check borrowing. The borrow would be something like let mood buff is self buff RW context. So context is the thing that has the permission inside, I would guess. Example 2, shared monitoring data. Yeah, we have like RC ref cell, and we have like 2 futures. One of them is just counting. Another one is also counting. And awaiting this first future. This is like this over here is very similar to just my example of the increment, right? So I guess the first example that we had, this example, right? So this example in Rust can be changed. Instead, it's like this doesn't compile, right? X is mutable more than one at a time. Over here. Cannot borrow mutably more than one at a time. So the way you solve it, one way we already showed with this being an argument, but you can also just make this to be a ref cell basically, or I guess just a cell, right? Just do ref cell here. X borrow and then this works, but the problem is that it checks at runtime instead of compile time. I want to I would like to know if anyone is actually using Ghost Cell though. Maybe a Q cell. So there's another crate, which is called a Q cell. Statically checked alternatives to ref cell and a read-write lock. It's like a little bit different, I guess. This one is 300,000. This one, Ghost Cell, is a lot less. Yeah. And then Token Cell is used 1,000,000 times, actually. How is it used 1,000,000 times? There is also Pure Cell, alternative to Ghost Cell that provides safe interior mutability via const expressions, whatever that means. Toast Cell, zero cost, type branded cells with no runtime checks. What is that? Many thanks to the Ghost Cell for pioneering this pattern and for creating the Ghost Cell trait. Hold on, how is Toast Cell different? Let's take a look. Type branded. Posted in Forjo. Type branded cell for aliasing checked at compile time. Based on Ghost Cell, but trades lifetime brands for type brands. Okay, so like the only difference is that the brands is not lifetimes but types. Create a brand type. Brand. All projects dead. All these projects dead? I don't know. I mean, they are all like very, very simple ones. I don't know if you like. If there is a lot of maintenance that needs to happen. Maybe Q Cell is even like older, actually, 2 years ago. I think this was like invented independently of the Ghost Cell. I don't know, maybe ChatGPT knows something about it. Any projects that use Ghost Cell or a similar approach? There are several real-world and academic projects. Rust Belt project uses separation logic and ghost ownership ideas to verify Rust programs. Rust Belt is the verifier for Rust. That's the verification project? Ghost Cell originated in this context, right? That's where Ghost Cell came from. because someone was trying to formally verify Rust, right? Peroxide, numerical computing in Rust. A scientific computing library in Rust uses GoCell. It's used GoCell experiment to allow mutability in matrix views while sharing ownership safely. Servo uses multiple custom smart pointers and sometimes similar ideas for managing mutability and thread safety, while not using GoCell directly. Servo explored branded types and internal mutability alternatives before Rust stabilized cell FCell. Crossbeam. Iris Cock. GoCell has a formal model in Iris and serves as a case study for capability-based aliasing and safety. Hold on. Capability-based aliasing, right? That's literally what... So like I call this system context system or like effect system. They call it capabilities. I think it's the same thing. We need to look at Iris, I think. So if maybe Iris is a language, a programming language... or something. Nice. Peroxide doesn't even exist. What's Iris? A framework for concurrent separation logic in Coq. Iris. Coq. The Iris project. Higher order concurrent separation logic framework implemented and verified in Rock Prover. Iris is a framework, so it's not like a programming language specifically, right? Concurrent separation logic for liveness. 2025. Is it like super new research or something? I mean, no, some of that is older. From 2019. Learning Iris. A logical approach to type soundness shows how Iris can be used to prove type soundness. What am I looking at? Monoids are not enough, of course. Iris is not just monoids for invariants, of course. A motivating example. We'll demonstrate the higher order aspects of Iris and some of core of its features by verifying the safety of the simple higher order program given in figure 2. Alright. Make one shot. So we have a lambda underscore. Underscore means that we ignore the argument. Is that it? Let x be ref. So like, okay, so ref. Okay, I can read this. In L is so in L and in R is the is basically an enum, either left or right. This is an either type. So this is a ref cell, either left 0, and this is either right with value n. And this is a ref, which is like this cell type, basically, right? Specification. Maybe like specification is actually easier to see. What is this? Make one shot. Yeah. We ignore the argument because this is a function that just returns two functions, I would say. What is one shot? Yeah, this returns like two functions, try set and check. Try set is setting the value to n. Yes, and check let y is not x in. So check is a function taking two variables, lambda f dot true. I'm not sure what check is about. So exclamation mark, I guess, is getting the value of x. X is a reference. This is basically cell.get, right? So we are matching the previous value of us and the new value, and basically we're saying that if it was set to n and now it is not set, then this should never happen. And if it was set to n and now it is set to m, then they are the same things. So I guess the idea here, make one shot, is this is a function that returns try set, and it only sets it once, right? And you cannot unset it, but you can set it to like the same value later. Something like that. C. For all v, I set v. All right. I don't know why I can read this. The specification looks a little funny with most pre and post condition being true. Oh, this is a pre and post condition? Oh, wait, so like precondition is true, means that like there is no precondition, and post condition is that W is true or false? What's W? No, I cannot read this. Specification. Specification like is like what? Like typing? The function one-shot allocates a one-shot location at X and returns a record C with two closures. Yes. Formally records are syntactic sugar for pairs. Yes, sure. The function C try set n tries to set the location X to n, which will fail if the location has already been set. CAS means set. If it is equal to 0, then it's compare and swap. Yes, compare and swap. X, it was 0 and now it's n. There you go. If it was basically none, and now it is some n. Yeah. So compare and swap. The function ccheck records the current state of the location X and then returns a closure, which, if the location X has already been initialized, checks that it does not change. Yeah. The specification looks a little funny. The reason for this is that we are aiming to show that if the code is safe, which is the assertion succeed, meaning that the branch with assert false will never be executed, and in the final branch n will always equal to n. In Iris, HOR triples imply safety, so we do not need to impose any further conditions. I don't know what's a HOR triple. Is this something from math? HOR triple. HOR logic. HOR triple. The central feature of HOR logic is the HOR triple. The triple describes how the execution of a piece of code changes the state of the computation. A HOR triple is of the form PCQ, where P and Q are the assertion and C is a command. P is named the precondition and Q is the postcondition. Yes, okay. That makes sense. right? So so the precondition is true, which means that we have no preconditions basically. But what is this? W is true or false? I don't even know what this means. And what's this star? Maybe I don't need to understand this. But this is supposed to be a motivating example. Since Hoare triples are just propositions, we can put them into the post condition. Since Hoare triples are propositions, we can put them into the post condition of make one shot to describe that the client can assume about C. Yes. Sure. So make one short is a function that returns C where for all V this, right? So this is the syntax, right? But this is basically W where W is true or false. And I don't understand, like, how is this useful? And what does this mean in the post condition here? It is worth pointing out that in Iris, is in a fine separation logic. All right. Which means that it enjoys the weakening rule PQ into P. Intuitively, this rule lets one throw away resources. So this is basically what they're saying. They have like the borrow checker, like in Rust. We have affine types in Rust too, right? If we have this, this is a star. This is a product type, which is a tuple of two fields of type P and Q. So if we have a tuple of P and Q, we can just get rid of one of them, right? Because it is an affine thing. We can throw away stuff. For example, the post condition, we can throw away ownership of unused memory locations. Since Iris is affine, it does not have the EMP connective, which asserts ownership of no resources. Rather, oh no, not more reading. I'm going to close this. Don't worry. I'm just researching what, like, if anyone like where else did the ghost cell idea get into? Because I know the ghost cell, but I don't know who is using it. So like I'm planning to use that idea, make a language, right? But maybe like that's what Iris is already kind of doing, right? Rather, Iris is true connective, which describes ownership of any resource, the identity of separating conjunction. So P and true is the same as P. We discussed this design choice further. So Iris is what? Is it like a proof assistant or something? I mean, this is a program, and then we need to prove it. So this is the specification, and then we need to prove the, and we need to prove it, right? Then we need to prove this. Is the idea, right? Ghost state in Iris, resource algebras. Iris allows one to use the ghost state via the proposition AY, which asserts ownership of a piece A of a ghost location Y. So I think this is basically a ghost cell with identity A, so like branded with Y, or like whatever is this Greek symbol being pronounced, and like the value A is living inside the ghost cell with ID Y. The flexibility of Iris stems from the fact that for each ghost location, the user of the logic can pick the type M of its value A, instead of this type being fixed in advance by the logic. For each ghost location, the user of the logic can pick the type M of its value A. For each ghost location, you can pick the type of the value. I don't know what it means. However, in order to make it possible to use A, Y in interesting ways, M cannot just be any type. It should have some additional structure. Namely, it should be possible to compose ownership of different threads. To make this possible, the type M have an operator for composition. Crucial rule of this composition is the logic. AB is A and B. The ghost operator. Okay, I think I understand this. So basically, let's convert this into Rust. Let's convert this into Rust. The idea is that if we have a cell, if we have a cell kind of A and B, we can from this get two cells, cell A and cell B. That's what it means. I'm pretty sure. It's really exposed that I didn't go to higher education. This definitely does not read the documentation. I mean, I'm skipping things here too, right? Also, some of this I can kind of read because because I was reading this other thing recently, the homotopy type theory, even although I didn't understand it much. Some of the things I did remember. I do remember. I cannot read all of it, but yeah. Let me just convert this this over here for you, just so that you understand what's happening in this code. Temp ARS. Let's do this. So we have basically, look at this. We have a function make one shot. This is a function that takes nothing and returns. It returns this thing, which is like called one shot, I guess. So a one shot, like this over here is untyped, I guess, like lambda, some like whatever this is called language, right? But it is untyped, and over here they provide the specification, which is basically the typing, right? So this over here, the specification says that our type will have the try set method, right? Function. We will have on the one shot, we will have a method try set. And I guess we actually like this is more like a trait, I guess. Trait one shot. Trait one shot where we have try set. Try set. So try shot T, I guess. Try set self and value V of type T. Right? And then we also have function check self, whatever this does. Let's figure it out, right? So this returns something that implements one shot, basically. And then this is just the implementation of this function struct result. So result has something, and result, and one shot for result. I mean, let's just, instead of doing this, we can have struct one shot. Fine, struct one shot T. We just have a try set is I guess a boxed in fn T, right? And then check is boxed in fn. We'll see what the actual here is. What's your editor font? I think we have this font command. Mm, yeah. So let's just read this code, right? This is a lambda underscore. Lambda underscore is basically a function that takes nothing. We ignore the argument, right? So that's what it is. It's a function. I guess like to convert this more like into just lambda syntax, we can make a closure, right? So we say function main. We say that like let make one shot is a closure taking underscore like this. You know, we ignore it. Of type unit, for example, right? So that's what we do, and then we return x is basically a cell new none, right? They say in L0, so in L is always used with 0 because like the value there is ignored. We can say that this is basically an optional thing. So this is cell none, and then we say that we return one shot where try set is box new closure. So we take n, right? This is what it is, lambda n, and then we do x dot. Wait, do we have compare and swap for cells in Rust? Cell. Swap. Update, replace. No. Well, I mean, they have this function compare and swap, which means basically that or I guess maybe like they even do this for multi-threading, so we could use like atomics. Maybe we can use atomics here. But this is an option, so probably not. Probably not. Let's just say this here. We will do compare and swap. Compare and swap x none sum n. That's what we do here. Where function compare and swap t, which has a cell t, previous t, now t or something, right? So we just say cell.get if cell.get is equal to previous, then cell.set t, set now, right? Something like this. This must be copy for cells to work. Make one shot, some languages leaking into Rust. Yeah. And then, so this is our try set, and then check is, once again, it's a lambda that ignores the argument like this, right? And then inside of this, we say let y is, so exclamation mark, once again, it's not a not. This is dereferencing the reference, aka x.get, right? And then we return another closure, which also ignores the arguments, right? So we do box new another closure, which ignores the argument, which we can just write like this. Or we can, I mean, we can just say argument with closure with no arguments. It's fine, right? Yeah, and then inside here, we just say match y and another exclamation mark x, which is x.get again, right? So we are matching this, and this must be, so in L means none underscore, then we don't do anything, right? If it is then if it is some n and none, then it should be unreachable, basically, right? Assert false. And if say some n and some m, then we assert that the n and m are equal. This is literally it. This is the translation of this code here. And then obviously this API in Rust, like yeah, basically we just we have this like runtime checks, right? But we can prove, right? We can prove this program that it never panics. That's what it does. We are trying to prove that this program never panics, right? Which is kind of obvious, right? For us as a programmers, because we are comparing and swap. We are only setting the thing once. That's why it's called one shot. We're setting this once. This is used in Rust for like in the logging, for example, I guess. Right? Down. Like we have this function in it, which is doing the same thing. Set logger, I guess. Right? This function may only be called once. So I guess something similar to that is what we're doing here. We are guaranteeing that the other calls don't do anything. Init or get. Yeah, I guess. Yeah, I guess this is something. Maybe it's something similar to the lazy cell. One cell. Let's see, one cell. Right. One cell. Get or init. Yeah. So it's called get or init, not init or get. So yeah, this is what we do, and the idea is that we can prove it. How is that doing anything with the ghost cell though? Not sure yet. So we have like this ghost cell with value A and lifetime and then ID and brand Y. Yeah. So we need to somehow encode the fact that we are only performing a one-shot update to X. To this end, we will allocate a ghost location with name Y and value A, which mirrors the current state of X. This may first sound rather pointless. Why should we record a value in the ghost state that is exactly the same as the value in a particular physical location? You get it. So if it's in a ghost cell, it means the bots haven't built it yet. Bots. Making factorial reference. The point is that using ghost state lets us choose what kind of sharing is possible on the location, right? Yes, ghost cells are about sharing. For a physical location L, the proposition LV expresses full ownership of L. What's V? Full ownership of L. And hence, in the absence of any sharing of it. Okay. All right. I'll try to explain this once I understand it myself. In contrast, Iris permits us to choose whatever kind of structure and ownership we want to for our ghost location Y. In particular, we can define it in such a way that although the contents of Y mirror the contents of X, we can freely share ownership of Y once it has been initialized. I call it triset. Yes. That makes sense. We cannot share ownership unless we like set the variable, right? This in turn will allow the closure returned by check to own a piece of y, witnessing its value after initialization. This in turn will allow the closure returned by check to own a piece of y, witnessing its value after initialization. We will then have an invariant tying the value of y to the value of initialization. Tying the value of x to the value of tying the value of y to the value of x, so we know which value that closure is going to see when it reads from x, as we know that value is going to match y. Another way to describe what is happening is to say that we're applying the idea of a fictional separation. The separation of y is fictional in the sense that multiple threads that own parts of y, multiple threads can own parts of y and therefore can manipulate the same shared variable by being tied together by an invariant. The Ghost Cell paper was easy to read. This one is written for someone else. A Ghost Cell is like for programmers, I guess. I mean, it uses Rust. Maybe that's why it was easier to read. What if the language infers the cell type you want? Well, I mean, the idea is that everything is a cell, right? Everything is a cell, and like we only need the ghost cell, right? Whenever I create a variable, it automatically creates the ghost cell for me. That's my current idea, right? Which is similar to kind of so in Rust, basically every variable is basically a ref cell, with the exception that it's checked at compile time. Right? But as soon as we create a borrow, another borrow cannot be created. Another mutable borrow, another mutable borrow cannot be created, right? It's like, which is basically the rules of the ref cell, or like a read-write lock, whatever. So a ghost cell is just more flexible. Fictional separation. What is this? Dots. Deny guarantee reasoning. Verifying custom synchronization constructs using higher order separation logic. The separation of y is fictional in the sense that multiple threads can own parts of y and therefore manipulate the same shared variable, x. The two being tied together by an invariant. Yeah. With this high-level proof structure in mind, we now explain how exactly ownership and sharing of ghost state can be controlled. Resource algebras. Yeah. So I was already reading this, right? So if we have a cell of A and B, we can split it into two separate cells. Well, I think we can do this in Rust cell already, right? An example would be. Wait, can we? Oh, there you go. S slice of cells. I guess this is a good example, right? We just have S slice of cells, right? So we have a cell of separate things, right? And we turn it into the separate cells. In this case, it's just like basically an array of two elements. Combination of ownership. If we have two cells with the same lifetime that do not make sense, combination of ownership that do not make sense should be ruled out by the logic. Combination of ownership that do not make sense should be ruled out by the logic. This happens, for example, when multiple threads claim to have ownership of an exclusive resource. To make this possible, this operator should be partial. What does partial mean? Composition of ownership should moreover be associative and commutative to reflect the associative and commutative nature of separating conjunction. For that reason, partial commutative monoids, PCMs, have become the canonical structure for representing ghost state and separation logic. In Iris, we're deviating slightly from this, using our own notion for a resource algebra. Resource algebra. Okay. A resource algebra is a tuple M, a V, M into prop, M question mark, dot, M. Hold on a second. So an algebra, wait, what is an algebra, right? An algebra is like the set plus the binary operation, right? So this is the dot, the composition is our binary operation. Algebra meaning. Wait, what is algebra? Who knows math? What's algebra? In the group theory, I guess, maybe? We have like, yeah, it's basically like a group which has the one operation which is associative, has identity and inverse elements, right? Yeah, so that's what it's saying, right? M is basically the group, which is like this set of elements, right? The type, right? So we have the operation, which is this binary operation, and then we have the inverse. So I guess this is how we call the inverse, M question mark. And what is that? I don't know. So we have satisfying the association, right? If we have this, then it's the same as that. Okay, sure. It's commutative. Core ID. Core ID. What's this? Oh wait, this is like the module. Whatever that means, I don't know. What's the module operation? It can be discarded, and module with itself is itself. What does this mean? Roll AB, A, M, and A, B. What is this symbol? What does this symbol mean? Then B and model A, model B. I'm not sure if I can read this. All right, maybe they partial commutative monoids. Yeah, they have their own thing. For all elements A and B, elements of M. I mean, yeah, this is what for all I understand. And this, for example, I do understand, right? We have this binary operation dot, which is like the composition, right? So for all A and B and C, A, B, and C is the same as A and B and C. Like this is the associative rule, right? This is the commutative rule. This is just like an operation, like this one, right? Maybe. So for all A, A is M, then this is that. Like they don't like like for example, they said that dot is a composition, right? They don't describe what this is supposed to be. I don't like reading just like abstract mathematical thing. Like this has a meaning, right? Why don't they tell me what the meaning is of this operator, right? Whatever. They only describe this composition operator. Looks like apps. Yeah, I don't know if it's apps though, right? Because if apps is apps is usually a function from M to M, right? But it's a function from M to M question mark, whatever question mark means, right? Like what does question mark mean? Or is this like the cell like ID branding, whatever? Like I can only guess here, right? This over here, right? They use the superscript to denote the branding of the cell, I think, right? But they don't use the this like dashed outline in this notation, so I don't know. The key differences, instead of partiality, the resource algebra use validity rule to rule out invalid combinations of ownership. Specifically, there is a predicate v prop indicated valid elements. So yeah, okay, there you go. I'm just reading about this right now. This over here is the validity rule, right? Which is identifying valid elements. Validity is compatible with the composition operator. Array valid op. Array valid op says that if A and B is valid, then just A is also valid, I guess. Whatever that means. What's prop though? If I'm like valid elements, whatever valid element is. Validity is compatible with composition. We will see that this take on partiality is necessary when defining the structure of higher order ghost state, which is ghost state whose structure depends on iprop, the type of propositions, and the Aris logic. So prop is proposition, right? When like we do proposition, it's just like some proposition, right? What exact like or am into prop. Okay, well, I mean it's some proposition, some validity rule. Okay. Sure. Think I understand. Instead of having a single unit that is an identity of every element, which is that enjoys this. Okay, that's how you usually define the identity element regarding the operator. Resource algebra have a partial function that assigns to an element A its duplicative core. So this is called a duplicative core. That's what it's called. It's not a module, it's a duplicative core. where duplicative core combined with A is the same as just A. The absolute value of this question mark, what does that mean? So a question mark is how you is like, this is like, I don't know, it's I don't know, like I guess this is the problem as with the other book. They show me the formulas and then they explain that later instead of explaining something and then show me the formulas. It's weird. You're supposed to read the book going back and forth or something. We demand that the we have partial function that assigns to an element its duplicate core. So like this duplicate core is idempotent monotone with respect to extension order. Defined similar to that for PCMs. An element can have no core, which is indicated by this being nothing. This is the void, the never type. In order to conveniently deal with partial cores, we use the meta variable a question mark range over elements of m question mark. I don't think I can understand this. Proof rules for ghost state. Invariants. So over here we have like this function, and then over here we have what, like proofs, right? What is this symbol? We have ownership. This value, is that what it meant? We have in L0 and pending y. Downtown. Derived forms of the ghost global state. All right, maybe we rage quit this. Another book. Why did I even start reading a book? Fuck the books. Okay. I don't like books here. More books. Hold on. Let me just see if there is like something that Iris project, right? Like, can this be described in human language? Maybe. What was I doing this one? You love books? Maybe you can read it and then explain it to us. Context-dependent effects in guarded interaction trees. Guarded interaction trees are a structure and a fully formalized framework for representing higher order computations with higher order effects. In COC, we present an extension of guarded interaction trees to support formal reasoning about context-dependent effects. That is, effects whose behavior depend on the evaluation context. For example, call CC shift and reset. Using the reasoning about such effects is challenging since the certain compositionality principles no longer hold in the presence of such effects. How would you name your language, COC? Why is COC named COC? It's actually kind of clever and a bit of a nerdy joke. Homage to Thierry Coquent. Coq is named in honor of Thierry Coquent, a French logician. So it's just like a name. And then it's also calculus of construction, COC. And a French wordplay, coq means rooster. A national symbol of France. And also it means cock in English. That's literally why they did it. They basically called it cock because it sounds like cock, right? If ChatGPT is correct. This is one of these really horrible names. You got a guy named Whore too. Yeah, it was Whore somewhere. I was just reading about it. I should rename my language to boobs. Affect and affine type and effects system. Effect handlers form a powerful construct that can express complex programming abstractions. They are generalization of exception handlers, but allow resumption and continuation from where the effect was raised, allowing continuations to be resumed at once, which is one-shot effects. One-shot continuations, or an arbitrary number of times for multi-shot, has far-reaching consequences. In addition to performance consideration, multi-shot effects break key rules of reasoning and thus render certain standard transformations optimizations out of sound, especially in languages with multiple references such as OCaml 5. It is therefore desirable to statically track whether continuations are used in a one-shot or a multi-shot discipline, so that the compiler could use this information to efficiently implement effect handlers and to determine what optimizations it may perform. We address this problem by developing a type and effect system called Effect, which uses affine types to track the usage of continuations. And a challenge is to soundly deal with advanced programming features such as references that store continuations with nested continuations, which are crucial to support challenging example from the effects literature. Another challenge is to support generic type signatures of polymorphic effectful functions. We address this challenge by using and extending Rust's cell type and Wadler's use types. Speedrunning books. To prove soundness of a fact, we model types and judgment semantically via logical relation in Iris, separation logic, frameworks, and Coq. What is Wadler's use types? Propositions as types? I know that. What's a use type, though? What is Wadler's use types? Use type refer to a type system idea that tracks how many time value is used in a program. Oh, it connects to linear types, affine types, and more broadly, substructural type systems. All right, we are getting somewhere. We are trying to find the correct book to read. I'm assuming, or something. The use types. Overview of effect. Storing continuations references. Let R is ref true. In R, do choose. And not R, not R. No, it's not, it's reading. References containing continuations, combining one shot with multi-shot, proving type soundness. Handle except. Enforcing a one-shot discipline via affine types. Let us consider some well-known effects from the literature. So like exceptions via effects, right? Except A is throw for all. What is this? What is this? choose 1b. I think this is a function that takes a unit and returns a boolean. B is a boolean, 1 is a unit. So that's it, right? And so this is the arrow which specifies the function type. Yeah, so this is for all y alpha into y. This means, yeah, so what this means, let me just translate this. I can read this, I think. Throw I can read this, I think. So basically it says that something like this: trait except a, where throw is a function throw which says for all y x for all y it takes like the we can call this exception basically of type A, and we return y. So the reason they are doing this is because this function actually never returns, so the result is of whatever type. In Rust, you, instead of doing this, you just say that throw is a function that takes exception and returns never, right? Which is basically the same thing. There you go. So this is what we have here. And then counter is we have the inc, which takes a natural number and returns a new natural number, and choice. Yeah, so like we have like these effects. Like, since we don't have effects in Rust, I guess it would be easier in Coca, but I don't think I can write Coca right now. Then we have counter, which says inc, function inc, x of type n, let's say basically int into int, right? And then and we have choice. So choice is the operation. We have the operation choose, which takes nothing and returns boolean. There you go. That's what all of this thing is. The intended semantics is that a throw aborts computation by throwing an exception, increments a counter by a given number and returns its previous value. Inc is an instance of the state effect, and choose non-deterministically returns a boolean. Those effects can be used as follows. So here is the example. Let's just convert the example really quickly. So we have a function example. Let's do example 4 here. Example 4 is a function that is unit, right? So we have unit, and this function returns n. N. Let's just say that this is n, right? And I guess we can just say that n is an integer, whatever, right? So example 4 is a function that returns n. So this is a function that says if choose, then we do inc 10. Otherwise, we return inc 20. So this does not work in Rust because we don't have effects. So effects, this is actually nice because this is how it's supposed to work in cast itself, right? We have effects, which in cast we say something like this: with choice and with counter. So this over here in cast would be something like current choice, current counter dot inc, and over here this would be current choice dot choose. That's how I would write it in cast. In Rust, we can model the effects with the arguments. So we say that choice is something that implements the choice, and counter is something that implements the counter. But it's basically like the implicit argument, right? So we have this, and we say like choice dot choose counter inc, and over here we say counter inc. This is literally this example just translated. The do keyword performs the effect. Yeah. I do not have the do keyword to perform the effect. I don't care about that. We have it implicit, but we could say that the effect is, I don't know, we could say that this is async or something. And then instead of the do keyword, we just use the await. So await is something that like basically does the effect. We can say like that, for example. All right, the first handler turns exception into an ordinary return value. Hold on. So we have the do keyword, which performs an effect. Function types are annotated with effect row. Yes, effect row, which is a list-like structure that tracks which effects are used. Effect rows only give the types of operations. Their semantics is given by a handler. Handle except, handle counter. Yeah, so like this is basically implementing a handler is basically implementing the trait and then passing it as an argument, kind of, right? So and also we have a function. Wait, what is this? Hold on. Handle except for all a, for all 0, a except a0, a. This is all the other effects, I'm pretty sure, because they are doing the effects with the rows. They say row, right? So they use row polymorphism. This is just all the other effects. So handle f by throw x. So k in this case is the continuation. Continuation has the effects which are the remaining effects because we are handling the effect a, but all the other effects still need to be handled. We just return. Throw x k x red xx. I'm not sure about the syntax, but basically the throw handler is just returning this value, right? The first handler turns exception into an ordinary return value, yes. The second handler threads through the state m of the counter. Yeah, whatever. Whatever. What is this about? Storing continuations in references. Enforcing the one-shot discipline in the presence of references is challenging. The key purpose of references is to share data. So we need to ensure the continuations in references are resumed at most once to maintain time soundness. Yeah, which is why we basically say that the choice, if we model effects as traits basically here, this should be not well, I mean, they talked about continuations. We don't have the continuation. Continuations only exist in handlers. But yeah, basically they should be they are resumed at most once. Yeah, so they are basically used at most once, which we can just model with the existing type system in Rust. Effects, reference, ref. So to achieve that, we take inspiration from Rust cell type. Effects references ref t correspond to cell t and are thus unrestricted. So references correspond to reference to cell t and thus unrestricted. Depending on whether t is unrestricted or affine, different operations can be performed on ref t. The store operation can be used for any type t. The load operation is limited to unrestricted types, such as basic types and unrestricted functions. So basically, cell.get only works for copy types. The replace operation, which stores E2 in in1 and returns the previously loaded value, can be used for any type. Yeah. Is that how it works in Rust too, right? If we have a cell and we have a method which is called replace, this works for any t. It doesn't need to be copy, right? Yeah, it's only get that is working with just copy types. So they're saying the same thing. Converting an iterator into a generator is more challenging. Hold on. To see references in action, we consider two interfaces to reverse data structure, iterators and generators, also called sequences or cascades, and convert these into each other. So iterator is for all this. Yeah, this is the effects. So basically, the quantification on the effects row in iter, allowing a client to use an iterator I with effectful function. What? So an iterator is something to which you give the function to consume the element, and then it gives you a function that just, I guess, calls your consumer. Where a generator is more like the Rust's iterator, which is a function that is returning the thing. Why is there no effect row here? Is this like a total function? Not supposed to be, right? The function list to iter. We have a list and returns a, simply calls the function f on each element of the list. The function list to gen stores the list in a local reference and returns this. Effects unrestricted references are needed here. This function checks if the list is empty and returns none, otherwise it returns the head and updates the local reference to the tail. Yeah, but isn't there supposed to be an effect here? To I guess you cannot observe. It doesn't. Yeah, like. So basically, they allow functions to be called multiple times. They mutate this. They mutate their inner state, not any of the other observable states. I guess is why this is treated as a total function. Yeah. Unrestricted references are needed here. This function checks the list. Yeah, whatever. Converting a generator into the iterator is easy. The function generator to iterator is implemented by repeatedly calling the generator and calling the iterator, the iteration function on the generated element. Yeah. Converting a generator into an iterator into generator is more challenging. To preserve the lazy behavior, the conversion can be done using control inversion, which is the combination of references and effect handlers. Let us first consider the simpler case of using an iterator to retrieve the first element. Let us first consider the simple case of using an iterator to retrieve the first element. So I have a function from an iter a. Basically, iter a, this is like in terms of Rust, this is not an iterator. Iter a is like it's like a loop, maybe, where in this case this function is the body of the loop, basically. So it already is consuming the entire like thing, and this is like the resulting function is one step of the loop, where the generator is just the iterator. We use the accept effect to throw an exception after the first iteration. The handle accept discards the continuation, aborting the iteration, return the first value. To implement iterator to generator, we use the power of effect handlers to resume the continuations and continue the iteration, similar to the way list to gen stores the remaining list. But now store the continuation is in a reference. The code is okay. So this actually, like, by the way, this is already done in cast. We have this. We have this. Let's have a for loop. There you go. This is it. This is literally what they are doing here. So we have a loop with I guess we want the yeah, this one, the for loop. The for loop is basically consuming a generator, right? So we have a generator, and if we have a generator, this is our handler of the yielding. This over here is handles the when a yield is happening inside a generator. So when a yield is happening, I don't have the continuation here though specifically. The reason is because the continuation that they have here, k, oh, it's because they return a function. Yeah, I have a different API. Oh wait, this is iterator into generator. Yeah, the difference is that I don't return a generator. I just like consume it all. It's kind of similar to what I'm doing though. Polymorphic recursive effects. Combining one shot. Okay, why am I reading this though? Why am I reading this? So this paper basically is about effects and how it works with ownership semantics, right? Subtyping of type signatures and rows. Rule of subtyping relation on type signatures and rows is shown. Is that? Sure. Ah. I didn't do anything useful, did I? I should stop. But I mean, the Iris project seems like it's researching these things that I kind of want to look into. Asynchronous probabilistic coupling of higher order separation logic. Contribution is probably in language theory. What is that? Mm. I don't know. Let's get to some useful stuff. What did I do? I still have something uncommitted. I did mutability. That is kind of checked now. The reason we were looking into that is because into things is because like this over here right now compiles, but it's supposed to not compile. Right? If I have a list and I get the reference to the element of the list, I should be able to modify it only if this thing is modifiable. Yeah, maybe like what I want, like since I was basically implementing the runtime checks for mutability constraints, not compile time, right? So we would have in our contexts the accesses that we have. When I define a mutable reference, I should add the access to mutate this thing, right? Which is why this should compile. But when I do this, we have only read access, which means that it should not compile. But right now, instead of like storing it in the context, I'm storing it right next to the place, which is actually wrong. So I should basically undo my entire commit, right? Mutability is not the property of the place. But then when we get to the inner when we get to the inner things, when I get to the inner things, so if I have access to mutate A here, then I should also have access to mutate all of the inner places, right? And how does that work? So that's why, yeah. Yeah, so like they had this rule in the resource algebra. What if it happens if I search for resource algebra? The authoritative resource algebra. This gives me the Iris project immediately, right? This looks like it's a presentation. So yes. Operational semantics. Basic logic of resources. Basic separation logic. Overview. Diagram specification of proof pattern. Wish to consider a situation where several threads operate in a shared state. Each thread has a partial view or fragmental view of the shared state. There's an environment governing its shared state. The invariant keeps track of what the actual state is. Counter module with 3 methods. New counter, increase, and read. Creating a fresh counter, increasing and reading the value. Abstract predicate is counter, is a counter. V is a counter whose current value is n. Okay. This counter Vn should be persistent, so different threads can access the counter simultaneously. Hence, is counter Vn cannot state that n is exactly the value of the counter, but only its lower bound. The new counter method creates the counter. The increment method, compare and swaps. Atomic operation. We do a loop. Yeah, compare and swap. And if it failed, then we try it again. Sure, the read method simply reads the value. Authoritative. We'll use invariant. The invariant will have the authoritative view of the value. A ghost assertion. Intuitively, this is correct. True value of the counter. We'll use invariant to keep track of the shared state, the value of the counter. Ghost assertion. Each thread will have a fragmental view of the counter, captured by a ghost assertion. This is a lower bound of the correct true value of the counter. And this is the correct one. We'll use an environment to keep track of the shared state of the module. Until a fragmental view should be duplicated. Several threads may share the same fragmental view. Several threads may agree that the lower bound of counter is n. The fragmental view is the lower bound of the true value. If we own both the authoritative view and the fragmental view, then we may update them. Carrier M. This is the naturals with 2 additional elements. Idea for mn natural numbers, write this for m0 and this for nothing n. Resource algebra definition. Boom, boom, ba-da-dum. So they call this the composition rule or something, right? If we have the cell with multiple values, we can split it into cells of separate values over the same ID, kind of, right? Say list get. So let me just think about this. We have a mutable array A, mutable list. I get the this thing. How do I know if the element if I have access to this? Maybe we don't do that. Right? Maybe this is where I would need to actually have like different types, because like similar to Rust, the indexing into a slice gives us an optional reference, and a reference is both the pointer and permission to like read the data there, or like write if this is mutable, right? So so I guess we should still have like references. And pointers separately. And then this would mean, so like while this element exists, while I have the reference to an element, I should not be able to read another element, right? While this element exists as a mutable reference, I should not be able to get the element at a different index, right? But this this works right now. Because I don't have the borrow checker, of course. So I think we basically have a combination, like I think we will have something like a combination of Rust. I mean, in order to have the ghost cell, we need to have like Rust ownership already, right? But but we still are introducing two separate things when I'm introducing like a new binding. Because a binding is not a reference. A binding is two things. The pointer and the access and the permission, right? But if I want to construct a reference, after all, then it turns into like the normal Rust semantics, where we store them next to each other. Right? Does that make sense? So basically, in order to construct a normal reference, we need the read access to this binding, to the place X. In order to construct a mutable reference, we need like write access to the place X. Okay. But then I need to so like we need to like differentiate. So basically in Rust we only have two reference types, right? The reference and the mutable reference. I mean yeah, and then I have a pointer. So I guess like this is three different ways. We need a third syntax, I think, to basically have a just get the pointer to the place without needing like if I only want to have the address of it. So maybe the idea should be that I have a mutable reference, or I have the read reference, or I have just a pointer. Maybe like this. Maybe we should do like this. I also think that this should also allow us to have an out pointers. Out pointers are used in some languages, right? So for example, I think I really like the idea of being able to say let x, so we don't initialize the variable, right? We don't initialize it, and then we call a function which takes this like the reference to this thing. We know that it is uninitialized, but we still can construct a reference so that it is like being populated, you know? Which means that we only have the write and not the read access there, kind of. Right? Although this should assume that it actually uses it. What's up, developers? Wouldn't be me. We looked at some books today, Raymarch. Have you seen Iris Project? On accident? Or I guess another question, have you learned about the ghost cell from me, or did you know about it before? Was there anyone who knew about ghost cell before? You don't know if it is the iris you knew about before? So I'm kind of like looking into how my I guess borrow checker should work here. I started implementing something and then I realized that like for it to work properly, I do need a borrow checker already. Like so basically mutability is not a property of a place, which is what I originally thought it would be, but it's not. Judge read through the paper but couldn't make it through. Yeah, kind of the same that what happened for me here. But following the idea of the ghost cell, in WGSL, immutable stuff is not a place, and any place is mutable. And what is immutable stuff then? A constant? But it's not a constant, right? I mean, immutable stuff should still be in places. What do you mean immutable stuff is not a place? A value? Just an abstract thing that can be put somewhere but doesn't have to. I guess it kind of makes sense, right? But since they are not places, it means that you cannot get a reference to an immutable stuff in WGSL. Is that right? You cannot get a reference because references only make sense for places, right? Because otherwise, how do you point to something if it doesn't have to be put somewhere? You're not saying that their design solves all problems. Okay, yeah. Okay, sure. So what I'm saying, like, let's see here. So following the ghost cell, we have the separation of like data and permission. So that's why I'm saying that so like a mutable reference, like in Rust, is actually like this type is the same as basically a pointer to the data, plus it is a like the mutable I don't know, it's something, right? It's like write access somehow, whatever write access is, right? So this is actually two things. A mutable reference is two things. This over here is a zero-sized type, which is only existing at compile time. And then, like, how do I specify something that I don't want to read and I don't want to write? I only want to point to things. That's just a pointer, right? So because of, like, this separation, I need separate, I need different syntax, I guess, for the pointer that I will want to read. Yeah, we can call it exclusivity guarantee. Sure, yeah, exclusivity guarantee, whatever. Yeah. I guess that's better. And then yeah, basically, what if we want to get this but without the guarantee? Then we do a normal thing, right? But if I want to read from it, then it's a pointer plus like guarantee that, like, I don't know, like what do you call it? But I guess like it's read access, whatever, exclusivity guarantee, or whatever is the other name for it, right? So we have like at least these 3 types of references, and then I think there we can because of that have like the 4th, which we can write to but we cannot read to, which is basically the out pointer. All right, I need a break though for 5 minutes. Guarantee that nobody else has an exclusive guarantee. Basically like exclusivity guarantee, like I guess this over here is exclusivity guarantee plus initialized guarantee. You know, like we know that it is initialized, this variable, and this over here is the out pointer is basically the exclusivity, but without the guarantee that it is initialized. No break was actually needed. So yeah, I think we should have these 4. Is this good? Is there languages that do that? Maybe potentially. So like this is just a pointer, like in C, kind of, and we can take a pointer even if the thing is not initialized. If the thing has moved out or something, right? Like we don't care. We can always take a pointer, and because we can always take a pointer, we can so like the advantage is being able to also do the like recursive data structures, right? So we say that we have a I don't know. Let's say this. We have node, which is like a pointer. So yeah, and we use the same syntax, I guess, for the types. This is how we get the value, and this is the type. So we have a pointer to type t. Can I even do that? Hold on, let me see. REPL. Can I do x is type, which is for all t, t and t. Expected type get template. Yeah. So yeah, this is not exactly a type. It's a generic type, which is a function that returns a type. So this type. You would make read the default and have place or something for uninit. You think? Yeah, maybe. Yeah, I was thinking about that too. Place is another alternative. I agree. And then X and out. Do you really like the exclusivity? Exclusivity, maybe like sometimes you want exclusivity without guaranteeing mutability though. Like mutability implies exclusivity. Can we have like a read-only place which we guarantee exclusivity to? Like, is that useful? Out is a write-only, yeah. Define mud in Rust should be X. Yeah, like, but what if you had a separate X? Like, you know, X is something that you can read. I mean, then there is no reason to it, right? If it's exclusive, then it's just like taking ownership of the thing. I mean, but at the same time, the same would be true for this thing. Like, what if we have something that is exclusive, but you cannot mutate? Would that make sense? I don't think it's a huge misnomer in Rust, saying that it's mutable instead of exclusive, because mutability just implies exclusivity, right? Like, for example, you have a read-write lock, and then you don't say a read-write lock dot get exclusive reference, right? You say dot read, or you say dot write. You know, you don't say dot get exclusive reference. Or would you like to do that? So anyway, let's say that we have a node, which is basically a generic type, which is the value of type t plus a reference to another node. Right? I guess we do... You know what? Let's have a separate example. Linked, doubly linked list. Let's do it separate one. It must be a module then too. Because it's a recursive type. I think I cannot have recursive types right now, actually. Should fix that. So node. Let's just say here that t is an int. Node is value. Type value is t. Previous is a reference to node, and next is a reference to node, right? So we want this to compile. And save. Most Rust functions are designed so that X allows mutation, but that's just the API that implemented the X stuff. But then some people start making tutorials when they say if you have a shared reference, you know nobody can mutate ref. And therefore you know you don't have to debug that part because it cannot change, which is false because of interior mutability. Well, interior mutability kind of like breaks things. I don't know. It kind of still. I don't know. Anyway, let's have this, right? The head. Let's just construct the thing with head and tail. So head is a node where value is 1. Head is a node where value is 1. Previous is so this should be like optional too, right? Optional node. Option Oh, so previous is none. Next is none. And we have the same for the tail. Values 2. Previous is some had. And then we say that had next is some tail. What will it say right now about doubly linked list? I think it will not compile because node is not found. I cannot have a recursive types right now, which is wrong. Does this mean that like the types should be lazily evaluated basically? We have the recursive context here, right? Like it expects the node to be specified before, and then we like kind of shadow it. Right. It's probably that people do with exclusive reference, but the mechanism in the language forces exclusivity, not mutability. Give you a net mut that you cannot mutate because the fields are private. It will still be exclusive though. Well, in order to mutate, you need to have both access to mutation and access to the like and knowledge about the thing that you need to mutate, right? You need to have permission to mutate and knowledge about what you can mutate. So a mutable reference is only giving you the permission, it doesn't give you the knowledge. The thing is to implement mutation on top of the mut. Indeed, that mut is not about mutation. What? I don't understand your point still. Exactly. Okay, this is not working right now, but let's imagine that it's working, right? Let's imagine that it's working. Is this so like over here, right? This should be an option. Let's use this like explicit cement syntax with a place, right? So this is just a reference to the place, which is basically just a pointer, right? A pointer is just pointing to a place. It does not give you the access to read or write or do anything with that other node, right? That's what it is. We get the place of the tail, we get the place of the head, but we cannot do anything about it, right? Now, how do I actually get the permission to mutate this thing specifically then in a language, right? So we would need to have the list. The list is basically the I don't know, head is a node, right? Where the head is just a node. But this the list if I have a list, then I should have access the list is not just a node, because just having the nodes doesn't give you access to the other nodes. It only gives you access to reading the value from the head, right? So we need other things, right? So I need here to have in addition the something. How would I write that even? For the purpose of that argument, I'll have to restrict it to safe Rust because otherwise everything falls out of the window. Send tells you whether something can be sent to another thread because of the trade bounds in the thread functions and because of the auto trade mechanism, right? Send tells you whether something can be sent to another thread because of the trade bounds and thread functions. Okay, sure. That's what the send trade is about. If you can or not send something to another thread. So yeah, this is just a pointer without me carrying the information that I can read this specific pointer, right? I'm kind of losing this information. In the example of the ghost cell, we would have the entire, like, in the node would be the so the node would be actually the thing that is generic over the arena. That's what they use. They use the word arena, right? Which makes sense. So I guess places, like place should still be always annotated with something. All right, or ID, right? We still need to have ID. So places need to have IDs. Which is like similar to lifetimes, right? So it's a place with ID. I think something like this would make sense for a syntax, right? This makes this just ties these two nodes to the fact that they are coming from kind of from the same place, which would mean that if I have access, so like access objects, right? Access objects are also having this ID, so I can read this place if I have permission to read the ID, right? That's how we tie the things together. So basically, if I have whatever exclusivity, read, write, access, we just call it access. Let's just say we have access to the ID, then we can read all pointers with that ID, right? We can do we can do whatever this access is allowing us to do with all of the pointers with the same ID, right? That's what we have. So which is why this is generic. This is similar to lifetime. This is basically the lifetime, right? But it's like a brand instead, a brand of the place. Yes. So now the this head and this tail, they kind of have different they have different IDs technically because they are different variables. They are different places, right? They are different variables. They are different places. So, but what's the situation if node next points to itself? Should it be able to? Yeah, I think it should be able to. Yes, it should be able to. Because why not? You don't want to strange the point too much because you know many people disagree. Can you like maybe you should like have a write-up or something? Just so that I understand what you mean better. What does mutable even mean? It means that the object changes its states during the lifetime. Well, yeah, it can change the states during the lifetime. Yes, I guess. Does it have to, but it can. I mean, okay, can we point to ourselves? Sure. Yeah. Yeah, I mean, I don't see why not. Yeah. Does it like when would you do that? I mean, I guess you like cache pointers to some nodes. In yeah, it is useful. It is useful. I have done that before, pointing to itself. When doing some like tree-like data structures, you have pointers around, right? And you can point to itself. I'm just like trying to like what is the specific? What would be the specific example where you would do that? I guess like I guess basically you can have the tree data structure, right? You can have tree, and this would be a tree where we have the like the left son, the left child, right? Left child is let's say optional tree, right? We have the right child, which is also optional tree. But we also have we also can do like, you know, the leftmost, which is always a reference, and I can have the rightmost, which I guess means that the nodes over here kind of can also cache this thing. Mode X discussion again. Hello, yeah. I mean, I'm not focused on mutable versus exclusivity too much. I'm just trying to see what we will have in the language and how will it work. So similar to lifetimes, we have IDs, right? And if I want to construct a place, a reference without needing access to that place, we just do this, right? So we have, so the types that we would have is reference, place, ID, right? This is basically a pointer. This is just a pointer, but pointers still have like these lifetime like objects associated with them, right? And then a pointer, so like a reference to place plus the access to the same ID, right? If I have this and I have that, then this is equal to like a new thing, right? So if this is an access that allows me to read, then this would be a read reference, right? A read reference is just that, right? And then write mute x reference is this plus like write access. Exclusivity without mutability makes sense. Not sure if it's useful though. Yeah, that's what I was asking. Is there is there any reason for wanting exclusivity without mutability? I mean, we already have it in Rust, right? You just you can have like a variable, right? When you say let x be some foo, right? This is an exclusive way, like, but it's not mutable, right? If this type is not copy, if you have not constructed the references yet, then we still have exclusivity, right? But we don't have mutability. But we don't do that when we're making references. But and would that make sense? It's not exactly X. Yeah, it's not exactly a reference. You have an example that shows how it's messed up? Alright. We can take a look. But yeah, basically this is the idea, right? The mutable, so this is like a lifetime in Rust. I think this syntax kind of makes sense to me. Yes. So we have like, so what we have is a place reference, which is like the language construct. Place something something. We have the read and the mutability, which is a place reference plus access. We can have the out pointer, which is place plus something about this idea, right? That we can like write. I mean, this, I guess this is a read write, and this is just write. Read, write, and write. Is that it? You use that muteself for making functions to be exclusively called, even although I did not mutate itself at all. Standard library does that too. I don't remember needing that myself. What is exactly the standard library doing it? Where? If you want to the function to be exclusively called, don't you just... I mean, exclusivity is not FN once, right? Yeah, that's a different thing. That has 4 kinds of references. Right now we only have 1, but we don't have like borrow checker. We're not checking anything, right? But in order to like borrow check, we need to have 4 kinds of references. Yes, I think. I mean, we can delete this last one. But it should be at least 3, I think. And I mean, Rust also has this 3. It's called a pointer, a reference, and a mutable reference in Rust. Rust doesn't have the out references, but it has all the 3. This is just called a pointer, right? So yeah, because like let's do this. You see over here, I'm mutating to say that the next is pointing to the place of tail later, but we should be able to just write this. We should be able to just write this. We have a head and we have tail, you know, like this. And we have the head is this. So you know how the tail is not initialized yet, but I should be able to take a pointer to it. I should be able to have a reference to it. So I should be able to say that next is already some place of the tail, you know? Like, we should be able to just construct it in one go like this, without, like, mutating later. That's basically how you would do it in C, right? You allocate the variable on the stack. You don't initialize it though, right? So that you can get just a reference to it. This should be possible. That's why we want the place references, right? Before the thing is initialized, we cannot construct the read or mutable or references, right? That's what it means. Out is also kind of like not exactly right. Because imagine if I'm writing a function that needs to initialize some data, right? So I have a function initialize a place, right, where we have like x of type like out int, right? I need to initialize an integer with an out reference, right? I don't want to be able to initialize it twice here. I don't want to be able to do this. So out pointer does not necessarily mean like mutability. I don't think this is the same thing. Mutability and right access is kind of like not exactly the same, right? Mutability means that you can write multiple times. But you can write just once. Is this just sugar for that? No, it's not. Because it's literally going to be compiled like I guess there is no alternative for that in Rust. But there is an alternative for this in C, right? You just say void init place, and then you say that star int x, right? But in C you just have no way to like specify that this is not initialized yet, but you can have pointer to uninitialized data. This is the this is what we want to have here. We want to have pointers to uninitialized data, right? And then you just say x is like 2, like this. So it's not exactly a syntax sugar. Because you can probably maybe you can store it somewhere else too, right? Does cast have safe, unsafe kind of distinction? Not exactly. Not exactly, but I guess like how do you get the access to like basically in order to dereference a pointer in Rust you require the unsafe. Does out mean you have to write? Yeah, I think so, which also means that this should be a linear type. So out references also require linear typing, which means that the out pointer must be used. If it's not used, it's invalid code. So out, this requires linear types. It must be used, right? If we construct the out pointer, then we must write to it. Yeah. Does that mean that out cannot be deconstructed with individual fields being handed into functions? I think it should be. No, I think it should be. Basically, yes. Yes, it should be possible to do that. If you have an out pointer to a tuple of 2 integers, you should be able to get out of that 2 out pointers. But this is a function, right? It's using this one to construct this one. This is a linear, this is still proper with linear types. The like basically constructing 2 out pointers out of a single pointer is the same as using this pointer. But now you must use this too. There's gonna be like partial borrows tracking which out pointers have already been written to before the object is fully initialized. It's going to be like partial borrows, tracking which out pointers have been written to before. I don't think it needs to like track the things. It's just like all we need for that is just linear types. A linear type means that this must be used somehow. So this is one way to use it, is destructure it into inner out pointers. We don't need any extra logic on top of that. Linear types means that I cannot drop a type. That's it. You need some explicit operation with this. So the 2 operations that you would be able to do with, I guess, the out pointers is destructuring it into like inner ones, or it is the actually writing, initializing the place, right? That's also using the thing. Right? And then you can only do it once. too. Although maybe like doing it multiple times, so maybe so linear types are types that must be used exactly once. Out pointer, like depending on what we want, it should be used at least once. Is there such types? Type that should be used at least once. Type theory. Let's ask ChatGPT. I think there is a name for it. If linear type can must be used exactly once, affine at most once, what do I call types that can be used at least once? Relevant types are those that must be used at least once. There we go. This comes from logic, right? So like, yeah, I guess, yeah. And then there's unrestricted to relevant types. It's a thing. Yeah, ordered use exactly once in order. Linear, affine, relevant, normal. Can you create your own reference something T? I guess. Like I'm not sure if this should be even like a language construct, or should this be just syntactic sugar? Like a mutable reference, like I said, is just two things, right? It's a pointer plus the access to mutate the pointer, right? So maybe this is just a syntax sugar. Yes. Maybe this is not a language item. The only language item is the place and the and I guess like the accesses or something. Like we would just have the basically read. Basically, inside of the standard library, I would just have a function read place. So in order to read place, you need to have the place itself, the pointer to the place, and you need the access, right? That because like that's how you read it, and then like basically dereferencing a pointer is just syntactic sugar for calling the function read place pointer and like pointer 0 and pointer 1, right? Because this is a reference with the thing. Although I mean it was like the access was more my idea was to have this passed through the effect system. So so I guess it would be, yeah, because like this function would be like read place with access with read ID, you know. This is done through the effect system, and this gives me so this gives me the T, I guess, right? So this is just yeah, this is the definition of the function, and then in order to like the syntax, like this syntax sugar just means read place pointer 0, and then we pass this into the context by saying with pointer 1, right? Which we can like name, right? So we can say that this is a pointer and this is the access, right? So we would say with pointer access a read place like pointer, or we call it reference or whatever, right? Something like this. It's just a syntax sugar. I think it can be just syntax sugar. I think with linear types you can build ordered types. You have type state pattern or something, right? I think so. I don't know. I haven't seen ordered types. Okay, here's another thing, by the way. I don't know if I ever talked about this. Maybe I did, maybe not. I want to have another kind of thing. Although this is even more raw thoughts than like about this. So the idea is I want to have something that I call branch types. Imagine that we have something, right? We have something like some resource. We have a resource which is some resource, you know, and then we have like branching, right? Something like an if. We have if true, then use resource in one way, resource, right? Else we say use resource in the other way, right? So we have these things, and now let's say that I want these two things to be just A and B. Like basically the idea that I have is that I want to always be able to extract functions. All right, that's the idea, which we cannot do in Rust most of the time. So what if I want to have like this body of the if extracted into a closure, right? Closure called A, right? So I would say A is a closure which just uses the resource in one way, like so, right? And this over here is B. So B is that. This is something that you cannot do in Rust, because it means that you are moving the resource into both of these closures, right? So I want this to also be possible. Borrow Checker hates this trick. Yeah. So I want this to be possible. How do I want this to be possible? So I call these branch types. So this is basically a branch. I don't know what's the syntax is, right? But it's a branch type with some ID similar to like these IDs, like lifetimes, right? We have a branch ID, and then like the actual type is a function, like so, which means basically that if I use any type with this ID, if I use a value with this ID, then I cannot use the other value with this ID. Is this done somewhere? This means that if I use this one, then I cannot use this one. If I use this one, then I cannot use this one. Sounds hard. I'm not sure if it's too hard. But and then you would also be able to have like, you know, like you would be able to store these two branches in a data structure, right? So so you have like branches is basically like how do you store the if and then both branches in the data structure, right? You say like that then case is a function, and else case is a function, right? But you need to specify that these two cannot be called at the same time. So you say that it's branch of ID, which is the same ID, so you make it generic like this for all ID. Something like this would be the type of this. I think Rust probably does something similar in the state machine behind async blocks. Yeah, maybe. But like you cannot do this. If you want to store something like this in a data structure, you would need to have unsafe, or you need to have like ref cells, right? So the way you do this in Rust, you store this resource. You store this resource in, I don't know, like the way I do it usually is just like, I guess, arc mutex option resource instead. And then when the specific function is being called, we just say resource log unwrap take unwrap, right? And like, because of the way we write this, it's like, and yeah, and then it will panic if I try to call the other closure after the first one, basically. But it adds overhead, right? And this will, if this is on the type system level, then we don't have the overhead anymore. I don't know, like to me this idea sounds really simple, but maybe it's not. I mean, using this idea is simple, right? Like this is understandable, I think. Implementing it maybe is hard. It's kind of similar. Actually, you know what? Now that I think about it, it's very simple. It's very simple. You know how to implement this? You know how to implement this? Basically, let's say that we have a, like, what is a branch type? A branch type is for all. So like we have ID and then we have the type, right? This is basically same as the type itself, kind of, right? It's just a new type over T. So the only thing is, in order to get T, we need to supply the proof that it has not been used yet, right? That's it. We just need to prove that it has not been used yet. So basically, when we it's like it's kind of similar to just passing this resource as an argument, right? But we are splitting the data from permission once again. It's literally the same idea, I think, as the ghost cell. Like, you know, you say that resource was not used is resource was not used. You know, this is over here. This is a 0 sized type, which we just use as proof. This is also like the normal like resource, which cannot be copied, cannot be cloned, right? So basically, I move into this function. Instead of moving the resource itself, we just move the proof that the resource was not used yet. We just move this. And obviously, we move it with the context system, right? So it is going to be implicit. So the code just looks like this. Which actually means that maybe maybe this is actually part of our pointers, right? Maybe this is part of our pointers. Like, you know, I want to have a pointer passed into a function. And it is not like how do we mimic boxes, you know? I think this is how we mimic boxes, basically. What's a box T in Rust? A box T is a pointer, right? It's a pointer. Just like a normal references, they are just pointers. But instead of having the read access or write access, in addition to just having the pointer, it's the ownership, right? So it's not exclusivity, it's ownership that we have. So a boxed is an owned pointer. That's all it is. So we have actually the fifth kind of pointer, right? The owned ID. Is the fifth kind of pointer. I think that's it. Pin. Pin is something that prevents moving. No, I think owned pointer is a box, not a pin. Box still can be moved around, or I mean, since this is a pointer, I guess. I mean, maybe it is kind of like. I don't know. No. I think no, it's a box. Pointer of the fifth kind. Oh, you mean as a 7th pointer we also need pins? Yeah. Yeah. I did not like think about movable types yet. But yeah, basically since we have an owned references now, right? So since this closure, this is literally working through the same mechanism then. It's actually really good. So if a closure wants to mutate, it only captures the pointer, and then it needs the mutation like access, right? It is going to be passed to it as a context, right? Implicitly. So like we split the pointer and the permission. So we capture only the pointer always, even if we take ownership. But in this case, the fact that we own is going to be passed into the function when we actually call it. But it also means that how do I... Like sometimes I want to store both things. Which I mean, so if I want this to be passed not through the context system, then I would just say that resource is like the owned pointer, which is like taking the ownership already, I guess. You have a weird question. Would it be possible for the user to somehow implement this kind of language level guarantees themselves? I noticed there are these things like type traits in C++, auto traits in Rust, mutability in Rust ownership, where language level stuff becomes part of the type system and lives next to other types. Could there be a way say object must get consumed twice? I think so, yes. Yes. So like I think on the language level we kind of... I think on the language level we need something similar to the Rust thing, and also like linear types. So basically, if you want to have the twice pointer, something that you read twice, right? It's basically the same as having the pointer itself plus two things. Let's say that we have a list of length 2, and every element in the list is the one-time use token. Right? You just do this. Like I said, the dereferencing a read pointer would be... So dereferencing a read pointer would be just a syntax sugar where we pass the access like as a context to the function. So like yeah, like these pointers, they are all just syntax sugars, I think. This one, the owned pointer, is just a syntax sugar for the pointer plus the ownership token for this ID. Like so that I don't have to wait for the language to innovate on something, yeah. Or like for Vulkan, I need to know beforehand where a resource is going to be used, but oftentimes the pipelines are very static, so the computer can totally know by static analysis in the type system. For Vulkan, you need to know where a resource is going to be used. What do you mean by where? Where is going to be used? Where means like... I think you do it with inference. Let's say that we have a resource that is only being used once, right? So like just a normal linear resource. So you have this ownership token, right? But basically, I think you combine the ownership token with the usage, right? So resource, I don't know, where is a resource used? Where is resource used is basically a type. It's a type. It's a generic type, I think, where the location. This is the location, right? So where is the location? I think. And then the token is ownership token, which also has the ID. So the ID of the resource and where is it being used, right? We need these two to be like connected somehow, right? So I think basically when you like, you know, you have like function, a generic function, which is generic over how is it? So you have a function to which you pass the ownership of the resource, right? So the resource, maybe like let's not think even about the token, right? Let's just say that for all location we have the resource itself. Resource is like the resource itself, right? So we pass a resource to the function which says where is resource used underscore, like this. This is something that Rust does not allow. So like in the function definition, you basically take as an argument the resource plus this, and then like for like something you like actually use resource would so I need to like bind this to a variable, right? Underscore as like something. I don't have the syntax, I guess. Well, I mean, I guess like the location. We do have syntax. We can say location is underscore like this. Like this is supposed to be inferred, and when I actually use the resource with like location, we like infer this thing, kind of like, I don't know. This is like a rough idea. It's not like moving between threads, but the different queues, like these there are these queues and you need to move buffer ownership between the queues. So like moving stuff between threads and the different queues also have different capabilities. And so if I move something to a graphics queue and do render, then the buffer needs to be initialized differently. With certain capability that reflects the usage in the queue. So it's the type of the resource, but nothing models. Yeah, maybe I'm not exactly understanding. Have you tried modeling it in Rust? It's not possible? Spent like a year or so. Try to do it in Rust. I mean, like what you said is that depending on where you move it, it needs to be initialized differently. So those are different functions that just take different types, no? Isn't that all of it? You missed a bunch of good conversation with Raymarge, I see. Yeah, we came up with the idea of that we have actually 5 pointers, not 3 and not 4. We need 5 pointer types in cast Spike. So we have a place. This in Rust is just a pointer. This in Rust is just a pointer. I guess mutable pointer. Right? We have the read access. We have the read pointer, which is in Rust just a normal reference. We have mutable pointer, which is in Rust just a mutable reference. We have the out reference pointer, whatever, which is in Rust impossible. Impossible in Rust. I don't know. Maybe it's like maybe uninit. Maybe it's something like maybe uninit. Yeah. But it requires unsafe. I guess, but I guess this is what it is. It's a maybe uninit. An owned pointer then is basically a box T. Project. The project is called cast. And we're not implementing much. I guess we were thinking about borrow about like pointer reference is borrow checking. So people anonymously decided to write so-called render graphs for modern graphics APIs as the correct solution for the problem, which are effectively a data cell where all it does is provide you the ability to do forward search into the graph to know how resources will be used in the future and optimize access for scheduling. Well, I mean, like, how is that different, Raymarch, from something like this? You know, you have the X and you don't specify the type, and then sometime later you say you use function X, and now since you know what the function of f is, right, now that you know that it is some specific type, you actually have this information over here, right? So based on this, you can do decisions over here, right? I also think that owned is on the heap. It should just be called box. It's not necessarily on the heap. I think box in Rust also is not necessarily on the heap, right? You when you have box, I mean, a new thing is being on the heap, but you can have from raw kind of, and this can be pointer to the stack. But in order for this to be like you can construct a box on the stack using like maybe an init, taking a pointer to that, and then like doing shit, you know. Yeah, just initialize some uninitialized data on the stack so that it doesn't get dropped. Well, I mean, I guess box is always freeing the resource, so it's different. Yeah, but I guess box is different because it's when it because it always is calling the destructor, the drop call. That's just too weak right now in Rust. I think what you're missing in Rust. I think what you're missing in Rust is the infiltrate anywhere. So like you basically in Rust you want to know some information about this. You want to enforce some information about this, right? So you want in Rust to be able to say infiltrate when you specify variables, I think. This is called existential types. It is like existential types Rust. Maybe it's already nightly, I don't know. Wouldn't this be enough for you if you knew if this implemented some trait, and then how specifically it implements a trait would be like figured out later, right? With type inference, you have infiltrate in return position, but it's yeah, in argument position it's a generic, so it's not an existential type here. So yeah, this means over here exists type T where T is bar, and that's what you want for your normal things too, right? Is there an RFC for that? For using it in other place, like over here, right? Type this is impl debug. Code using the RFC. Okay, where's the RFC? Link. Type alias infiltrate. I guess this one. Yeah. There you go. Existential type. Is this merged? RFC PR. It is merged, right? So we're going to have this at some point. What's the implementation status? Permit infiltrating type aliases. Subscribe. Implement the RFC. It's implemented. Wait, what? It's implemented already, so we can just use it. Infiltrate in associated type. Also. Basically the same thing. Maybe this will be allow you to do it. You can maybe try this in nightly to see if you can do it. Pretty much. Alright, anyway. I did nothing today. I think I will revert this code that I wrote today because I will do it in a different way. Mutability. I mean, I can merge this for now. This is better than nothing. It checks for the fact that I mark stuff as mutable at least a little bit. Missing the VIP badge. Done. Alright, anyway. Good progress on the thinking, I guess. Trace return and trace already unstable. Yeah. I know. I use it all the time. Alright, I need to go. You wrote cult with a T. Cult is pronounced C-U-L-T. Alright, see you guys next time. This dude is also making compiler.